Good morning, good evening, and good afternoon, depending on where you're joining us from today. We would like to welcome you to DevOps Virtual Summit. Before we get started, we'd like a little bit of housekeeping. We do have subject matter experts with us today, so if you have any questions, please pop them in the chat window, in the Q&A window, and we will get to them as quickly as we can. Also, on the bottom left-hand corner of your console, you will find a resources area, so any links that I mentioned today would be accessible there. Right below the resources widget, you would find a survey. We would love to hear back from you, so please provide us any feedback you would have for today's session. Finally, this presentation is recorded and you will receive a copy of this presentation in your email within 48 hours. With that, I will hand you over to the speakers for today.
Hello everyone, and welcome to the DevOps Summit. I'm Donovan Brown, and I'm very grateful that we have technology that allows us to continue to connect virtually. It's this type of technology, born out of a digital transformation, that I'm here to talk to you about today. The world has changed drastically, and it's important that our companies and organizations change as well. It's pretty safe to say, the world runs on code. You interact with code even if you don't realize it. Code impacts everything that we do in our daily lives. It affects the way that we travel. It's the way that we communicate, entertain ourselves, educate ourselves, and depending on what apps you use on your phone, it might be the way that you fall in love. The digital world permeates the physical world in a very profound way. Over 90% of business leaders have realized that when they start this digital transformation, it sparks innovation. It excites their people to try to create new and amazing things. 85% of companies have also realized that if they do not do this, this could be detrimental. They could become irrelevant. We have many examples of this already. Netflix displaced Blockbuster. Uber has disrupted the taxi industry. They use technology to change our lives in fundamental ways. By 2026, nearly 50% of the S&P 500 will be replaced. As a leader, you need to innovate. You must change the way you think about infrastructure. Think about your infrastructure as resources that you use and then throw away when you no longer need them. Start utilizing the true power of the cloud for your infrastructure. Start rethinking the apps that you design and try to get your apps to blur the lines between the physical world and the digital world. Finally, harness the power of the data you collect. We're collecting tons of data, but very few people are utilizing and harnessing information inside that data. Start using that data as telemetry, as insights that you can use to build better products and services, to engage your customers in new ways. Companies that do this, they outperform their peers many times over, and it shows in their profits. Make sure that you're not the last to realize this, because the first to innovate sometimes wins. Even if a competitor comes later, that's better. Some argue that Lyft, the competitor of Uber, is a better app with better services and better features. However, Uber was first, and first for so long, they have a share of the market that is very difficult for Lyft to overcome. Being the first to innovate is strategically important. If you're not innovating first, you're risking becoming irrelevant. Because digital transformation is an economic imperative. You must do this because this is the world that we live in today. And I believe technology will find new ways to embed itself into our lives. What I'm going to do now is play a video. This video is going to show that no matter what industry that you're in, no matter the size of your organization, a digital transformation is extremely important.
No matter what industry you are in, whatever types of customers you serve, your organization is transforming. Today, more than ever, you need to rethink what is possible and become more resilient for a changing world. You need to embrace new ideas, processes, and technologies grounded in a strong sense of purpose to empower each other, our communities, and the world around us, with security, continuity, and resilience being top of mind. Data drives information, information drives insights, and insights inform decisions and create methods to help you respond, recover, reimagine. New business models, new products, new markets. It's no longer just about one simple software solution. To reimagine your business, you need to create a connected, efficient, and scalable digital ecosystem. It's time to transform and think about your own future as a digital company. How? Through customized industry solutions built on an integrated cross-cloud platform that empower your people with the right technologies and products to achieve more. That seamlessly combine leading business intelligence and productivity solutions with the power of the intelligent cloud and intelligent edge, where you can build your own digital and technological capabilities with the unique support of the largest partner ecosystem. It's time to take the next steps in your digital transformation journey. Your vision, your data, your customers, your future. Today, Microsoft. Empowering every person and every organization on the planet to achieve more.
I really like that video because it does not focus on the technology. It confirms that you must engage your customers differently. Companies must empower their people to use the data that they already collect to wow their customers. Think about infrastructure differently and utilize the cloud wherever possible. Finally, transform applications so customers can engage with products and services from anywhere. I'd be remiss if I were to tell you that digital transformation is just about moving workloads to the cloud. It's much more than that. But digital transformation is the phrase that we've latched on to that means engaging with customers, empowering employees, rethinking infrastructure, and reimagining products and services. Cloud computing is a powerful enabler of digital transformation. Moving to the cloud comes with many benefits. The cloud enables management from anywhere. I remember I used to run a website out of my home. I used to have a huge rack with several servers in it, and if I ever left town, I'd have to call my mom and say, "Mom, I need you to go to my house and reboot that server for me," because the server was acting up or running out of memory. It was ridiculous. But with the cloud, I can manage my infrastructure from anywhere. The cloud provides infinite scalability, which enables high availability and elasticity. When you work on-prem, you have to purchase enough machines for your peak load. For retailers to survive Black Friday and Cyber Monday, they must provision enough servers to be ready for those 2 days out of the year. The rest of the year, those servers are not used, but they're there, depreciating, being maintained, and updated. They're a liability. To make matters worse, by the time you need them again, they're obsolete and need to be replaced. In the cloud, you just use the infrastructure that you need, and when you no longer need it, destroy it. I remember when I needed a server, I'd have to send an email. It could take days, weeks, or even months before I could get a machine. That wasn't very agile. With Azure, I can have a machine in a matter of minutes. The geo-distribution of Azure helps with support for disaster recovery. Azure can place resources anywhere in the world to ensure that if something bad happens in one area, a copy still exists in another. As much as we don't want disasters to happen, they do, and we must be able to respond. With new services being added to Azure all the time, teams innovate faster using cutting-edge technology. The cloud also allows companies to switch from CapEx to OpEx. I already described capital expense, where you must spend large sums of money up front to purchase and maintain the servers that you potentially will need. Switching to OpEx, any startup in the world can get started with Azure because there's no upfront cost. You don't have to buy servers up front for Black Friday and Cyber Monday. When traffic spikes, use the elasticity of the cloud to scale up to what you need, and then scale it back down. There's no maintenance, no racking and stacking. Your engineers are focused on delivering value and not on maintaining their infrastructure. When we're talking about the cloud, we're talking about 3 different types. One of them is the public cloud, like Azure, which is owned and operated by a third party. The third party is responsible for the hard drives, compute, storage, networking, power, air conditioning, security, and everything else required to run a data center. There is also private cloud. I want to be very clear. Your data center is not necessarily a private cloud. A cloud provides IaaS, PaaS, and SaaS services, which we'll talk about in just a moment. It is not just servers sitting around that you happen to use. Those are just servers in your data center. A private cloud offers IaaS, PaaS, and SaaS services to your engineers, but is completely hosted and owned by you. Where a lot of people are going to be living for quite some time is the hybrid cloud, where some of your resources are on-prem and some of them are in the cloud. When migrating, you don't have to rip and replace everything. You might leave your database on-prem and move your web service to the cloud and be able to communicate securely between them. Let's examine those services I was talking about that makes a data center a cloud. It's not just the machines, it's the services that we provide on top of those machines. The most familiar and easiest to think about is infrastructure as a service. That is where you run a virtual machine that is hosted by someone else. IaaS is like buying a car. You're responsible for the oil changes, getting the tires rotated. With IaaS, you must patch the server. You have to reboot it when it's time for a service patch. You own the entire VM just like you own the entire car. When you go to platform as a service, it's like renting a car. And you know how we treat rental cars. You drive them like crazy, you have a blast in them, and then you just throw the keys back to the poor person behind the desk and say, it's not my problem. The cloud provider makes sure that the disks are still good, that the memory hasn't gone bad, that the cables are still good on the network, that the operating system has been updated and patched. They deal with all of that for you. In my opinion, PaaS is the sweet spot. It's where I always want to be when I'm thinking about the cloud. Then, to the far right is software as a service. It's like calling an Uber. This is where the entire application is hosted for you. Examples are Gmail, Office 365, and Azure DevOps. These are complete SaaS offerings that you access from a web browser. All you provide is the data. The infrastructure and the application are managed for you. These are the types of services offered by a cloud, be it private, hybrid, or public. Another way to compare them is by looking at the different responsibilities that you have as you migrate from on-prem to PaaS. This is not a complete list, but some of the things to consider when running a VM on-premise. The responsibilities include networking, racking and stacking servers, the virtualization, OS, middleware, runtime, data, the application, everything. With IaaS, a cloud provider takes care of much of that. Plus, it's familiar. It's comfortable. You understand what a VM is, and you can move your application without changing anything. You can run the same versions of Windows or Linux. You can run the same versions of Tomcat or IIS. It's easy for you to migrate there. You can also scale them out much quicker because there's infinite scale and capacity in the cloud. With PaaS, which is really taking advantage of the cloud, it takes care of everything. In many cases, you don't even need to know the operating system that is running behind the service. It might be Linux or it might be Windows. But as a developer, why do I care? If I'm using Node.js, Java, or .NET Core that runs on any platform, I just need to make sure that the platform is up, and that's done for me by Azure. As a developer, all I worry about is the code that I write and my data. Everyone's journey to the cloud will be different. However, this is a migration pattern that I see a lot with existing brownfield application. There's a website running on-prem, on Linux, or on a Windows VM. What some do is just move to infrastructure as a service and lift and shift. Spin up a VM with the exact same version of the OS. Open the same ports on your firewall and copy your application to this VM. Now you can start to take advantage of some of the things that the cloud has to offer. You might also be able to move to PaaS on Azure using App Service. This is an amazing service that allows you to take a WAR file for your Java or your .NET zip file for your .NET Core or even your full .NET Framework applications and just run it inside app service, and they'll just work. This is also true for databases. We have databases for MySQL, PostgreSQL, and SQL Server. You provide the data and the schema, and they will just run. Now you're no longer dealing with the server, the reboots, the restarts, service packs, and all the stuff that comes with running a VM. Then you can start to modernize your application and start using the power of serverless and containers. Design cloud-first microservices architecture. Expose APIs so that you can use low-code or no-code to empower every employee to add value even if they're not a developer. I have learned that digital transformation and DevOps work together. But what is DevOps? I get asked this all the time. What I like to do now is share a video that I think really sums up what your company can look like before and after it implements DevOps. And we'll discuss the video after.
But Holland comes in for a pit stop. Time to refuel and change tires. Lou Moore himself changes the tires. Only 4 crew members, including the driver, are allowed to work on the car. It's a tense time. Holland stays in his seat, anxious to get away. Let's watch. Tires are changed at last. A crewman polishes the windshield as Holland moves away just 67 seconds after he stopped.
When I saw that video, I said, that's it. That's what people should be trying to do. Go from the first pit stop to the second. If you know anything about me, you know I'm very, very active on Twitter. So what I did is I tweeted that video and I said, DevOps before and after. Most people got what I was trying to say, but a couple people challenged me and said, there's no value in the second pit stop. I'm thinking to myself, how can they not see this value in the pit stop? And I'm sitting in my office and I'm reading these tweets and I'm clearly having some type of physical reaction because my wife walks in and says, what's wrong with you? I'm mumbling under my breath. How can they not see that this is an incredible analogy for DevOps? So what I want to do right now is I actually want to focus on 2 of those people's comments. One of them was that there were way more people in the second pit stop than the first. And the other person said they didn't even refuel the car, so there was clearly less value in the second pit stop than the first pit stop. Well, I blurred their names and their pictures on the tweet because I didn't want to embarrass them. But I did not delete the tweet. So if you're curious who these 2 people are, you can actually find them on my Twitter feed. But let's talk about the very first thing, the increase in the number of people. I live in Houston, Texas. I actually live right down the street from Compaq Computers, which is where I started my career. And I remember working at Compaq, when I was done, Donovan Brown, writing software, I would go into a server room full of ProLiant servers connected to the internet. These are production servers. It was just me and that server. I would pull out a tray, type in my password, and it would say, welcome Donovan Brown, and I could do whatever I needed to that machine. Change registry settings, delete files, copy and move files around, whatever I wanted to. It was just me and that machine. Then I would get my files on there, get everything running, then I would run out of that room as fast as I could, and now it was the IT pros' fault. Anything that went wrong, they had to deal with it. It was awesome back then. But try that today. There are simply more people involved in every step of deploying software. Dev, Ops, QA, the janitor, the PMs, the marketing team, everyone seems to have their hands in deploying software. I can't go and touch the physical servers anymore. They're either in the cloud, and even if I could touch them, I would definitely not have admin privileges on those particular items. What I thought was interesting is that not only are there actually more people involved in deploying software, I didn't see these people as people. I saw them as automation, continuous integration, continuous delivery, infrastructure as code, all these techniques and best practices that we string together so that we can deliver software faster than we ever have before. The more I review this video, the more I see parallels to what happens in the DevOps world. They improve the tools that they use, as you should do as well. In the past, they were using a hammer, and I didn't even know you could use a hammer to change a tire, but now they use something called an impact wrench. He's also built in redundancies into the process. Because if you notice, everyone that's responsible for removing a wheel with an impact wrench, behind them is another impact wrench, just in case the one that they're holding fails. There's a person in the back that has a jack. Behind him is another person who has a jack, just in case that jack fails. Redundancy built into the process. You also notice the two gentlemen up the upper right-hand corner, they never move. They are looking at a 2-second, 3-second pit stop, trying to figure out how they can make it faster next time. They're monitoring, and they're going to use that data to go back and make the system better. You should be doing the same. Before you make a change to your DevOps pipeline, measure. Monitor what happens, and then measure again. That way you know if you've actually improved this or not. If you look at the center of the car, there's two individuals there that are just holding the car, securing the car onto the jacks. DevSecOps is extremely important. The more I look at this, the more I see parallels in what's actually happening today on our DevOps landscape. But to me, they're automation, not people. Now let's talk about the second thing, shifting left. This is where we're talking about they didn't refuel the car. Now, I don't want to get into the details of F1 and the rules about if you can or can't refill cars anymore, but what I want to do is focus on the fact that refilling the car, that wasn't even the bottleneck. If we refill the car at the same pace that we did back in the 50s, today, we would still have drastically reduced the amount of time. Because changing the tires is what took so long, not refilling the car. But what we actually did instead is we made it so efficient, the car. We shifted left technology and innovation such that we don't even have to refill the car. Because trust me, if that car needed fuel to finish the race, they would have put fuel in the car. If you're focused on them not refilling the car, you're missing the point. It's not that they did not refill the car. It's that they did not have to refill the car. Shift left as much as you can so that you can go from the first pit stop to the second pit stop. Focus on what hurts most. And what hurt most was changing the tires. And I'm sure at some point they got good at changing the tires. And they realized that, man, this poor guy pouring the gas, it's taking too long. We got to figure out a way to make that faster. And what they did, instead of making physics faster and trying to push fuel faster, they simply made the car more efficient. You want to go from the first pit stop to the second one, where you're doing more than you did before, in less time, being more efficient. And that's what I want to help you talk about today. It's how you can use DevOps to go from the first pit stop to the second in your own company. So what DevOps means to me and to us at Microsoft, DevOps is the union of people, process, and products to enable continuous delivery of value to our end users. The most important word is value. This is not about software. It is not about features. It's not about getting to the bottom of your product backlog. It is about delivering value to your end users. When I meet a lot of customers, they tell me that Donovan, our dev and our ops team, they don't seem to like each other. I'm like, why do you say that? Because they're always pointing fingers at each other. They're always arguing with each other. If anything goes wrong, it's always the other person's fault. And then I ask them, how do you incentivize your team? It's like, oh, that's easy. We incentivize our operations teams by keeping the lights on. It's uptime, reliability. Green lights on servers is good. We want them to keep the lights on the servers green. Like, that's fair enough. How do you incentivize your developers? Oh, it's all about innovation and features and pushing out features as quickly as they possibly can. Like, you do understand that if we go back to the first motive about keeping the lights on the servers green, keeping it healthy, the easiest way to keep a healthy server healthy is not to touch it. But you just told your dev team, go attack the servers and change them as much as you possibly can. These two teams are incentivized to work against each other. What we need to do is reframe the way that you motivate both teams and motivate them both with the word value. The operations team should get the accolades and the affirmation and the bonus and the rewards if they can prove that they delivered value. Go to your dev teams and say the exact same thing. I'm going to give you the big bonus and the accolades and the pats on the back if you can prove that you delivered value. Now their North Star, their goal is exactly the same. And to achieve that goal, they're going to have to work together. Don't have two teams trying to achieve two different goals. Give them a common goal, and you'll see them instantly start working together. The other word in here is products and process. Those are the easy part, right? The products, most of us give those away for free. There's lots of great selections out there. And I don't want you to get buried around in the tech, because that is the easy part. The process, pick one. Agile, Scrum, Kanban. Just start producing increments of shippable software. But the people have to understand that DevOps is not a nice to have or an option. It is imperative. You either implement DevOps or you lose. So focus on your people, have them follow a process, and enable them with the products so that you continuously deliver value. So why is DevOps important? Because it increases your velocity. It allows your teams to go faster than they did before. It allows to automate a lot of what used to be manual, which reduces your human error. It allows you to still stay competitive because your competition, they're already doing this. You can't be the last to figure this out. If you're wondering how your competitors are innovating so fast, updating their applications so fast, chances are they've already figured out the importance of DevOps and started implementing it. And if you're the last to figure this out, you're going to be the next blockbuster. And we don't want that. So let's make sure your people understand, they get on board, and we start implementing DevOps in your company. So what makes up a DevOps pipeline, which is what most people focus on? A pipeline starts with a commitment to code to a repository. So developers inside of their IDE of choice, they're making some code changes, and they're going to push that code to a repo. What that should do is trigger something called a pull request. Inside your pull request, you're going to have a build that runs. That build is going to be able to run unit tests, static code analysis, security scans, whatever you need to verify that this piece of code is a good piece of code that we're ready to ship. After that, you're going to want to automate as much as you possibly can. Run unit tests, performance tests, load tests throughout your pipeline, test early and test often. Then what we're going to want to do is distribution. And we're going to have to be able to distribute this application, be it a web app, app services, whatever it is that you're building, you have to make sure that you automate the distribution of that as well. And once it's in production, you got to start monitoring it. You have to make sure that what you delivered is actually value. If you deliver the top thing on your product backlog, but no one uses it, you did not deliver value. And what you can do by putting the telemetry into your code is be able to verify that what we just delivered indeed was valuable to our customers, and we should do more of that. If the telemetry tells you that it's not valuable, look at the priorities of your product backlog and maybe adjust them. Try some experiments. Ship out another feature and see if those numbers are better. If they are, do more of that and do less of the other thing. And then finally, get that engagement and that feedback from your users. We want to make sure we understand what is actually giving them that value that they're looking for, helping them solve the problems that they have to solve. You can't assume that you know what your customers need. The telemetry can tell you a lot, but nothing's better than hearing it directly from your customers. Ask them for surveys throughout the product. Ask them to give you feedback. Give them the ability to give you a smile or a frown if they find a part of the product that they like or they dislike. You have to make sure that your engineers are engaged with your customers so they understand that they're delivering value. And what I've noticed is when I allow my customers to talk to my engineers are more motivated. They see how the changes that they make to the software impact actual users. It's not just numbers on a chart or slides in a PowerPoint. These are actual stories that they're hearing directly from the people that use their software. It's very motivating for your team. So this is what we're trying to do when we build a DevOps pipeline. And we want to automate as much as we can. We want to focus on the part that hurts the most, and then rinse and repeat this process, constantly looking to go faster than you did before. Continuous integration. Continuous integration is the practice upon every time a developer commits code to a repository, the code is downloaded, compiled, tested, and packaged for deployment. This is a crucial part of being efficient at DevOps. What I would encourage anyone to do that does not have continuous integration running right now is get it started tomorrow. It's instant value for you as an engineer. And you don't have to ask for permission to do it because it affects no one but you. If you're working on a team, no matter how big this team, if you want to implement continuous integration, you can do so and no one on your team will even know that you did it. Because they're going to keep committing to the same repository, and every time they do, your CI system is going to kick in. Download it, compile it, test it, and let you know if the code is good or not. And if it's not, let you know so that you don't pull the latest code and have a broken build on your machine. You get instant value for investing 15 or 20 minutes of your day to go set up a simple CI system for your company. And that one day when you come into work and everyone's at the water cooler talking about the person who just broke the build, what's going to be really nice for you is you're going to continue to work because you knew not to go get the latest version of the software because your CI system told you it was broken. When they come to your desk and wonder, hey, didn't you get a latest today? I'm like, no, I didn't get the latest code today because my CI system told me it was broken. What's a CI system? Oh, it's this cool system where every time you guys commit code to the repository, it tries to compile it for me, and if it fails, it lets me know so that I know that the build is broken and to stay away from it until someone fixes it. Like, wow, that's amazing. Can I get in on that? Sure. Give me your email address. I'll have it email you as well. Don't go ask for permission to set up a CI system because they'll say you don't need it because we've never had one. But set it up and let the results speak for themselves. It's going to allow you to move faster than you've ever done before. So I highly encourage you, if you don't have CI, set it up immediately. Once you have CI working and you're able to produce an increment of shippable software in a package that can be deployed, you move over into continuous delivery. Continuous delivery is where you're taking that package and you're deploying it from one environment to the next environment to the next environment. You want to make sure you do the exact same thing in every environment. That way you're testing your deployment, you're testing your process, you're making sure that it worked in dev and in QA and in staging and will work also in production. It's really important to do the same thing every time because you're building that confidence and that trust. And you don't want to deploy everywhere but production automatically. You want to prove that it works over and over again so that when you get to production, everyone has confidence that it's actually going to work. Continuous delivery is the next step after you have a really fine-tuned continuous integration. Now, deployment is where you're actually going to take that information and allow you to do all the gates I was talking about. So you have dev, QA, and prod. You don't necessarily want the code just to run through that pipeline with no breaks. What you want to be able to do is actually control the release of that. You want to be able to put approvers before and after environments so they can verify that the code looks good and should it be promoted to the next environment or not. Release management is what gets you that. The ability to control the flow of the code, reject it if it's no good, and promote it if it is, and make sure that there's no human beings touching the zeros and ones or the bits, but they are involved in the process, getting the code from the fingertips of your developers into the hands of your users. Quality is something that cannot be overlooked. When you're starting to implement DevOps and you're starting to implement continuous integration, you start to move really, really fast. And the fear is we're moving so fast that we're potentially going to introduce bugs that weren't there before. How do we go ahead and fix that? Well, there's no reason for you not to be testing. Like I said in the video, shift left. Unit tests should be written by your engineers and your developers. They should be executed during your during your continuous integration, so that they're actually testing the code every time a developer makes a commit. You should also write integration tests, load and performance tests, security tests, pen tests. All that can be automated and applied as part of the deployment of your software. So don't think about quality as something that you bolt on later. Quality should be something that you're designing into the product. Your developers should be thinking about that at time zero, not after they are code complete, waiting for the mountain of bugs to come pouring down from QA. QA's job is not to go find those bugs. It's to verify that there's quality in your product. Your developers should be preventing those bugs by testing early and testing often. Continuous monitoring is the process of make sure that you monitor as much as you possibly can. Are we getting 500s? Unhandled exceptions? Are our customers using the code the way that we think they're supposed to be using the code? Did that new feature that we just add actually be implemented and used by our customers the way that we expected them to use it? Because monitoring it is what tells us without any shadow of a doubt, without any guessing, if the application is performing the way that we think it should be performing. Like I said before, without monitoring, we're just guessing. We think we know why it might have failed. We think our customers are using that particular feature. There is no reason for us to be guessing. We have technology that allows you to monitor from memory usage to CPU to feature usage. And I encourage you to be monitoring throughout your process. Not only the app while it's running, but also monitor how long it takes to get from one stage of your deployment to the other stage. There might be a bottleneck in there that you can go back in and fine-tune. I want you to measure everything that you're doing, not just your app running, but even what it takes to get your features from your developers into the hands of your users. Now let's put this all together and describe some of the architectures you can take advantage of when you move to Azure. The first example is the high availability multi-region web application. A multi-region architecture can provide higher availability than deploying to a single region. If a regional outage affects the primary region, you can use front door to fill over to the secondary region. This architecture can also help if an individual subsystem of the application fails. This is taking advantage of the geo-replication provided by the global presence of Azure. Employing techniques like infrastructure as code makes duplicating your environments very easy. Being able to have a data center in America and another somewhere in Europe reduces the chances of those both being affected at the same time. The next that we will explore is based on Kubernetes and containers. Containers are a fantastic tool to add to your toolbox. This reference architecture shows a microservices application deployed to Azure Kubernetes Service, or AKS. It describes a basic AKS configuration that can be the starting point for most deployments. A microservice is a loosely coupled, independently deployable unit of code. Microservices typically communicate through a well-defined API and are discoverable through some sort of service discovery. Finally, pure cloud native. This is where you're thinking cloud from time zero. Even our inner loop as developers change. I'm developing inside containers. I'm building inside of a container. A container is a first-class citizen in my development process. What I'm able to do is push an image through my pipeline using an image registry, then deploying those exact same images to my production infrastructure. This might be your end goal, but you don't have to start here. No matter what architecture you select, DevOps best practices should be employed to enable smooth deployments. To learn more about this, you can go to Microsoft Learn. This is not a sales tool, it's a training tool. A lot of the content I use to build this deck comes from the modules inside of Microsoft Learn. You will learn about the fundamentals and best practices of the cloud and DevOps. Then, the Azure Fundamentals Learning Path teaches you about the data centers and redundancy, scale and OpEx versus CapEx. We learn about the power of the cloud when you are embarking on your own DevOps and digital transformations. Thank you so much for spending this time with me, and I look forward to hearing about your successful digital transformations.
Hi, and welcome along to this talk on Azure DevOps and GitHub, what you need to know. My name is Anthony Borton, and I'm based in Brisbane, Australia. I'm a DevOps architect, and for the past few years, I've had the privilege of working with some of Microsoft's largest customers to help them accelerate their DevOps transformation. Earlier this year, along with the rest of Azure DevOps engineering, I transitioned over to our new home, GitHub, and the future's looking really exciting. I'd like to hand over to my co-presenter Ian so he can introduce himself.
Hello, my name is Ian Choi. I'm a developer product marketing manager in Microsoft APAC based in Korea. I really love developer communities, so I usually go to many developer communities and try to figure out what are actual real blockers for their developer productivity, for including their account. GitHub is my very favorite tool, and I have been leading some Azure DevOps hands-on labs. And also then recently I have been investigating on how GitHub Actions are very helpful for developers in communities and also in accounts. So this is the agenda today. So Anthony will first explain how software development is changing, and also then he will explain then how Azure DevOps and GitHub integrate together with his nice demonstration. And then I will explain code spaces for seamless integration with DevOps, and also then I would like to take an example of scenario for how to extend from inner sources in one company to embrace more open source communities with cloud infrastructure, cloud world. And Anthony will conclude and share some useful resources. Okay, then let me hand over to Anthony to listen to how software development has been changing.
Thanks, Ian. Let's get started. Disruption affects every industry, and no company is safe. We've all heard about the now classic examples of Blockbuster being ousted by Netflix, Lyft and Uber disrupting the traditional taxi industry, and even Twitter changing how we consume news and media. Half of the companies in the Fortune 500 in the year 2000 are gone, replaced by organizations that deliver value faster, better, and cheaper than incumbents did, and now they're facing much the same fate. Technology plays a central role in a disruptor's ability to execute and out-innovate their competition. There are three powerful trends at work affecting how we build software today. Firstly, we have an insufficient supply of developers. Enabling developers with their preferred tools is one key to recruitment and retention of staff. Secondly, 99% of code bases include open source software. It's essential to secure your use of open source and pay close attention to your software supply chain. And thirdly, companies are struggling to adopt DevOps, which evidence shows is critical for success today. 93% of implementations are not optimized. So let's talk about a fictitious company, Coffee Roasters Incorporated. They're a great company. They're selling their ethically sourced single origin coffee out of their shopfront, and then the pandemic struck. They had to pivot. They had to rapidly ramp up their online presence, moving from a static website to a secure e-commerce site. Their small development team of developers decided that they wanted to host on Azure. They wanted to use ASP.NET Core, so they looked around and they found that Nop Commerce is the #1 e-commerce solution for ASP.NET Core, and it's been downloaded over 3 million times. So in making that decision, what they've done is they've added the work of 91 contributors and nearly 12,400 commits before they even get started. Nop Commerce is open source, and it has a variety of dependencies that it's built on. I'm choosing just one of those dependencies, Humanizer. Humanizer helps make developers a bit more productive, let's say. By adding that dependency, the team's adding the work of another 184 contributors, and over 2,000 commits. And I've already said that they decided upon using ASP.NET Core, which is open source. So now we're adding an additional 621 contributors and a staggering 44,953 commits. Now, that's not all of the dependencies, mind you, that's just a handful of them. What you're seeing here is that for a small team, before they start writing any code, they're already using the combined work, energy, and effort of a team of over 1,000 contributors. That's the power of open source. Now, after looking at the coffee roasters' approach and how they're building their online e-commerce solution, it should come as no surprise that in modern applications, up to 90% of the code comes from the open source community. For some people, I suspect that's going to be quite an eye-opener. When we consider open source components, almost all of that open source code lives on GitHub today, which is the undisputed home of open source across the planet. You can see on the screen some of the most well-known open source projects that are out there today. So in light of what I've shared with you, it really makes a lot of sense that in early June 2018, Microsoft announced that it had reached an agreement to acquire GitHub. Azure DevOps, which has been incredibly successful, empowers thousands of our customers with over 15 years of innovation focused on enterprises in particular. It's been the sweet spot for Microsoft. Now we're taking it and bringing it together with GitHub, which is the home of the world's open source software and has over 50 million registered users as of June 2020. That's extraordinary. The first steps we've already taken is to merge our engineering teams so that Azure DevOps and GitHub share the same leadership. Nat Friedman heads up Azure DevOps as well as GitHub, and that shared leadership's been in place for quite a while now. We're making sure that the engineers who are responsible for the platform, both Azure DevOps and GitHub, own the code that's running in production. We get to bring all of the insights, all of the lessons we've learnt from the past 15 years with Azure DevOps over to GitHub. Microsoft has over 25,000 employees using GitHub with over 10,000 public and over 2,000 private repositories, split over various GitHub organizations like Microsoft, Azure, and Microsoft Docs, to name a few. And they're leveraging all of the GitHub features, including GitHub Actions and GitHub Packages. In addition, Microsoft runs multiple installations of GitHub Enterprise Server. Microsoft also has tens of thousands of repositories in Azure DevOps today, and we're evaluating what's required to move those over to GitHub. We're working closely with each team to find the best solution and transition path for them, not interrupting their workflows and letting them focus on their business. So one of the biggest challenges that our customers face is which tool should they use? Microsoft's stated strategic direction over time is definitely GitHub. Our goal is, over that time, GitHub is going to develop a gravity that's going to pull in developers who want to work in GitHub every day. We're not about to close the doors on Azure DevOps. It'll be years away. We're continuing to innovate in both products, but I think you'll see that things are a lot more exciting in the GitHub world. So I guess what it comes down to, currently there's not feature parity between the two products. Today, in my opinion, the best solution is Azure DevOps plus GitHub. Now, fortunately, there are some great integration options available today to allow customers to use both Azure DevOps and GitHub together. Let's head into a demonstration now and take a look at the integrations that you see here on the screen. We start in Azure DevOps, where the Coffee Roasters Online team has just completed their daily stand-up. I head back to my desk, ready to start on my next piece of work. I'm already familiar with this nasty bug, so I'll drag it from new to active to indicate that I'm now working on it. Let's assume this bug requires some coding work to resolve. I'm going to switch over to my favorite editor, VS Code, to complete the work. I have the Coffee Roasters Online website folder already open and ready to go. So first things first, I'll make sure I have the latest version of the code before I continue. A quick git pull takes care of that for me. Next, I'll create a new branch for this work. It will be a short-lived branch, and we'll delete it once we merge the change back into main. Note the way I identify the purpose of the branch by including the work item number in the branch name for convenience. I'm going to make a simple change here. It'll allow me to demonstrate another integration a little later on. But for now, let's imagine I've diagnosed the root cause of the bug and implemented the fix in record time. Normally you'd execute and test the code, you'd write or update the required unit tests and more. But in the interest of time, I'm going to commit my change, add my commit message, and publish the new branch up to GitHub. This is one of those do as I say, not that I do things. I'll switch over to GitHub in my browser, and you can see I am notified of my recent push. I'll go ahead and create a pull request to evaluate whether or not we want to accept these changes into main. What I want to do now is to link this pull request back with the work item that we're working on in Azure DevOps. I want to link to this bug, but also once the PR has been successfully merged, I want to transition the bug from the active to the resolved state automatically. I can link to the work item by entering AB, short for Azure Boards, the pound symbol, and then the work item number. Prefixing this with the word fixes will take care of the state transition for me. There are other options available here, but this meets our criteria nicely. I will then select Megan Bowen as the reviewer and myself as the assignee. Finally, I'm ready to go ahead and create the pull request. Triggered by the creation of the pull request, Github Actions fires a number of workflows that have been configured. Specifically, we check to ensure the code builds successfully, unit tests are being executed, and CodeQL does dynamic security scanning of the code, and more. I'm going to switch over to another browser instance where Megan Bowen is completing her review of the pull request. She can see that all of the automated quality gates have been successfully executed, and after reading through the code, she's happy to go ahead and approve my change. Now that all of the workflows have completed, I'm going to switch back over to Azure DevOps. Note that the bug is still in the active state while the PR workflows continue. When I open the bug, you can see that the pull request we created in GitHub has been successfully linked to our bug. One of the integrations I've configured is the sync pull request to Azure Boards extension. I've created a custom work item query to return a list of all open pull request work items, as you can see here. Our current pull request is at the bottom of the list. If I open the work item, you can see details of the pull request right here within Azure DevOps. I'll return to the sprint board now, and you can see that bug 2165 has now automatically transitioned from active to the resolved state once the pull request was successfully merged into main. What you've seen so far is the Azure Boards extension allowing us to easily link our commits to work items in Azure DevOps. We've also seen how new pull requests created in GitHub can result in a work item being created automatically in Azure DevOps to give us great traceability. Now I'm going to head back to the code screen in GitHub. Ooh, this doesn't look too good. You can see I've been notified that a potential security vulnerability has been found in one of my dependencies. This is a great feature in GitHub called Dependabot. Dependabot automatically scans the main branch to see if your code references any dependencies that have known vulnerabilities. Dependabot works by periodically scanning your main branch, looking for dependencies, and checking the version you've referenced against the database. One important thing to remember is that just because everything was clear when you built, scanned, and deployed your application to production last week or last year, a vulnerability in one of your dependencies may have been found and reported in just the last 24 hours. Dependabot works reliably in the background, working to ensure you are notified as soon as possible when a vulnerability is found that could compromise your application. We can learn more about the actual vulnerability by clicking into the notification. Another great capability of Dependabot is that if it finds any dependencies with vulnerabilities, it will not only notify you, but it will also create a pull request to fix the problem for you. Typically, these pull requests simply bump the version number of the library from an old version to a more recent version where the vulnerability no longer exists. I'll switch over to Azure DevOps again, and I want to show you the results of another extension you can install from the GitHub Marketplace. This extension, called the Vulnerability to Azure Board, automatically creates a work item in Azure DevOps to ensure there is visibility to any vulnerabilities that have been found by Dependabot. You might also notice a second work item here for the pull request that was created for the suggested fix. You can use some of the existing functionality in Azure DevOps to conveniently display this information in dashboards. In this simple example, you can see there are 2 Dependabot vulnerabilities open at the moment, and you can also see a chart of the last 7 days when both of these issues were found. Now we're going to move on to the next integration I want to show you, the Issues to Azure Boards extension. For many GitHub users, creating an issue is a very common activity. It's been a key feature in GitHub for a long time. If you're setting up a hybrid environment, there may be some team members, such as the developers, that will prefer to work with issues natively in GitHub, while other team members may prefer to use the Azure Boards interface. Fortunately, there's another integration that can help here. I'll create an issue here in GitHub with a title and a short comment. I'll then assign it to myself for the purposes of the demonstration. If you wanted, you could add labels and more, which will also be synchronized over to Azure DevOps. Once the integration executes, you can see that my issue has been updated with a hyperlink. You can see here the link is AB for Azure Boards and the number 2170, which is the newly created work item over in Azure DevOps. Clicking the hyperlink takes us over to Azure DevOps, where we can see the issue work item that's been created. You can see the assignee has been synchronized over, and there are a couple of labels that have been added to the issue. There's also a hyperlink added to the bottom of the issue, which allows us to quickly and easily open the issue back in GitHub should we wish to. There you have it, the Issues to Azure Boards extension. Now, to round out our demonstration on different integrations, there are 2 more that I want to show you, and they both focus on Cicd integration. In the first scenario, the team from Coffee Roasters Online is using GitHub as the source code repository, but they want to use Azure Pipelines a little bit longer while they learn more about GitHub Actions. I'm going to head over to the GitHub Marketplace and search for Azure Pipelines. As you can see, I already have it set up in my account. Now let's go into Azure DevOps and create a new pipeline. I'll choose GitHub as the location of my source code, complete any authentication requirements, and select the appropriate repository in GitHub. I'll choose ASP.NET Core as the build template for my application, and you can see the pipeline's YAML file for my application's now ready to go. I'll likely want to review this and probably make some changes, but for now, I'm simply going to click Save and Run. I'll add a commit message and commit the file into the repository. As you can see, Azure Pipelines has kicked off the build and is fetching my source directly from GitHub. My pipeline will also automatically trigger every time a new commit is pushed into GitHub, as you'd expect for any CI build. In the final scenario, I'm going to talk about one where the Coffee Roasters Online team have been evaluating GitHub Actions and are ready to use that for all of their continuous integration builds. They're not ready just yet, however, to start using GitHub Actions for the release part of the workflow, as they've invested in creating Azure Pipelines for the release and they wish to keep using them just a little bit longer. So let's start by opening the GitHub Actions workflow file that they're using for their CI builds. I'm going to click Edit to allow me to change this file, and in the panel on the right, I'm going to search for the Azure Pipelines action. I can easily copy the YAML snippet and paste it into the appropriate location in my YAML file, but on this occasion, I've already configured the variables I need for connecting to Azure DevOps. I'll commit my updated YAML file into GitHub now, and as a result of this, the CI build will automatically be triggered. Let's head over to Azure DevOps and confirm that our release workflow has been triggered. Oh, there you go. You can see that release 32 just appeared, and the Coffee Roasters Online website is being deployed into the dev environment. Once that deployment has completed, a manual approval will be triggered so that I can easily decide to continue the deployment into the next region once I ensure that it meets any criteria I've set for the dev region, of course. Alright, so that concludes our demonstration of some of the integration options available to you to work in a hybrid environment with both Azure DevOps and GitHub. I'll now hand you over to my co-presenter Ian, who has some great things to talk to you about.
Thank you, Anthony, for your great explanation with so nice demos. I would like to start to talk with development tools for seamless DevOps integration. Development tools bridge between two directions. One is from planning stage to development stage. For example, how to realize with actual programming codes with nice manners. And the other kind of direction would be from development to collaboration. For example, then to store developers' codes, multiple developers' codes into one central GitHub repositories or Azure repos, and also then how to follow with coding conventions, great coding conventions among multiple diverse developers. Yeah, like this picture, collaboration stays at the middle, which implies that it is very important stage for seamless DevOps integration, and for developer tools are very important to bridge between planning and collaboration stage. So it enables very seamless DevOps integration through development tools. Okay, then I would like to talk today how code spaces enable seamless connection. Supporting both Azure DevOps and GitHub, code spaces really reduces our time to set up many development environments from hours per week to seconds. For example, for me, then I'm using my laptop, but when I move from one place to the other places, and then sometimes I need to use different laptops, or then when new developers come, and then they need to figure out what development environment is and how to install VS Code or some additional dependent libraries. It might be very tedious stuff. So, powered by web-based version of VS Code, or using the desktop version of VS Code, and by connecting into code spaces, and then it fully integrates with seamless GitHub developer experience powered by GitHub code spaces. So, it is currently on beta stage. So then let's see then how GitHub code spaces really enable for seamless collaboration. So my demo is based on usual Git VS Code experience on desktop apps. This is the general experiences on using desktop apps. But however, then let's see how DevOps GitHub code spaces completely work for seamless DevOps integration. Okay, here is my sample repository to demonstrate GitHub code spaces today. So to see with GitHub code spaces, then I can just go to click Code tab, and then you would see this Open with Code Spaces tab when you already applied to use GitHub code spaces for beta purpose. And then after I click, then I already prepared to store with previous status, it is automatically stored. But anyway, then let's click with the tab, and then after waiting for just a few seconds, and then it automatically loads Visual Studio Code on my web browser, which is very cool. And then it seems that the experiences are quite similar as the desktop version of Visual Studio Code. So, for example, then I can easily change the color theme. For example, then I personally prefer to use dark color theme. So in that case, and then I can go to preferences, and then I can change GitHub dark theme like this way, which is very cool. Also, then color syntax highlighting is automatically supported. So when I'm manipulating markdown files, and then I can also see not only color syntax highlighting, but also I can see how it previews like this way. And also then it supports with color syntax highlighting on source code files like this way, so which is very cool. And then finally, then it automatically syncs with source control. For example, this is the clone version of this source code repository. So then let's see, for example, that when I'm manipulating just this markdown file by purposely pressing some enters, and then I would see that, oh, yeah, there are some changes on my source codes, and then I can add to a stage, and then let's just add test commit message like this way. And then after clicking this, and then this commit message is posted, and then commit has been uploaded on this code space GitHub code spaces environment, but not in this environment, because for GitHub, then you might need to push your result. So then you can click the Git Push functionality, which has been automatically integrated. So for example, then when you are setting up new desktop environment, and then you might need to configure your name and your email aliases, and also then you might need to configure some additional extensions like Python or any kind of extensions for Visual Studio Code, but those are installed and stored. And even though I unexpectedly closed the web browser, and then it is very easy. I can go code spaces tab and reopen again. And then all the things, such as not only for color themes, but also then where the rest stages should be stored. And like this way, the color theme has been preserved automatically. And finally, then since I already pushed my source code, and then finally then I could see this test commit on my sample repository. Next, I want to explain by emphasizing collaboration and delivery parts. How Azure DevOps and GitHub helps for better productivity, especially on collaboration and delivery. So at the beginning of our presentation, then Anthony took an example of coffee roasters team. For example, then from small team to embrace with more open sources and then inner sources like this way. Then from now, then I would like to take an example of another case when their businesses are growing so fast and fast. So initially, the size of coffee roasters team would be very small, but as their business grows, let's suppose that the business has been rapidly grown with both regional in their country and with global scales, local branches, global partners. Since there are so many branches and partners globally, the team decided to extend from some part of inner source to open source. Like this picture, Open Roaster API is a private repository for inner source, while a new repository called Roaster API Community is a public repository to welcome so many developers, global open source developers, for discussion and collaboration, then enhancing some features or reporting some missing features and so on. Note that the features and functionalities on two repositories can be a little bit different. While Roster API focuses on inside Azure AD integration for internal employees and partner companies, then Roster API community would more focus on global payment system integration or authentication for better security to support many global kind of standards. And then I would like to additionally highlight that open source does not mean just opening a repository. Then this would be a very important point. Usually then open source would imply then opening a source code repository, but there are some more additional stuffs like how to document for new developers, new open source developers to figure out what this open source is, then how they contribute with by seeing API specification, then how they work with this open source repository and so on. And also then open CI/CD with reviews would be another important part. Now then there are many pull requests from many open source developers globally when the business size has been growing. So then in that case, and then some tests cannot be done with manual manner. So the automatical testing with some review bots or testing infrastructure would be really definitely needed. And also then some spaces for open source community developers would be needed, where to discuss together or where to report some missing features or some bugs and so on. So then let me take an example of an architecture on inner source with Azure DevOps. So then in this company, in this team, then Roster API private repository has been using Azure DevOps internally. For example, the Azure Pipelines are mainly being used to test with CI and CD for their internal development. And the Azure AD has been widely used for integration or authentication with so many internal employees and also some partner companies. And some features on serverless like function apps on Cosmos DBs has been widely used to maintain their internal infrastructure or resources and so on. And Azure monitoring services also has been using for monitoring details. And to extend from inner source to open sources, and then this would be a sample architecture. So then as business has been rapidly growing, then they might definitely need to preserve existing inner source architecture rather than for open sources such as Roster API community repository for public, then it can be integrated with Azure Static Web Apps for public-facing documentation for developer communities, and also the Github Actions can be used for public-facing CI and CD stuff for all the open source developers globally to see how CI/CD is going, and then also the Github Actions can be integrated with internal Azure DevOps pipelines, which is very cool. So let me take an example. Let me show my demo with Github Actions and Azure Static Web Apps for open sources. On this demonstration environment, then I would like to show a simple Hugo app for public-facing general documentation, and also then I will demonstrate with Azure Portal to show how Azure Static Web Apps look like. And also that I would like to emphasize how GitHub Actions can be used to coexisting environment with inner sources and open source environment. So let's see how it goes with my demonstration. This is a sample repository, private repository, Roster API to be already integrated with DevOps internally. For example, as you see this commit message fix AB #453, then this is Azure board number. So then one specific commit has been automatically integrated with Azure board stages. And also then when you see this file, Azure Pipelines.yaml file, this is a sample YAML file, but as you see, then it describes then how CI/CD pipeline works with Azure DevOps. While then this repository is for public-facing source code repositories to embrace many open source developers globally for coffee roasters team. So then when you see, then there is no YAML file to declare Azure DevOps, while then there is Github Actions on GitHub/workflows directory. And then it uses another license, MIT open source license, while then this code repository use private license for companies. And then let's see then how this repository works. And there are two parts. One part is roster API, which is actual source code on community version of roster API from the private repository. And then again, another part is documentation infrastructure. So those are documentation for this sample app, web app. So then you can see that, oh yeah, this is the description on this community, and then you can see API spec or about company introduction for more details, and then it links with a specific GitHub repository or organization, and also then you can see with RSS feed and so on. So then let's focus on how GitHub Actions can be described with Azure Static Web Apps. So then this web page has been developing with Azure Static Web Apps. And then when you register Azure, when you create Azure Static Web Apps on the top of Azure portal, then this file will be automatically created initially with skeleton. So then I tweaked some a little bit more for demonstration purpose. But yeah, let's first see then how Azure Static Web Apps look like on Azure portal. So this is Azure portal, and I already created Azure Static Web App resource. This is still a preview, but it will be on general availability status very soon. So then when you see then the configuration and all other things are very simple, but it also supports some additional features such as the role management to restrict these web pages for specific authenticated users, or then it also supports some many kind of DevOps stages with multiple branches. For example, what are staging version of web pages and what are production version of web pages, and so on. Another kind of great thing is that it is automatically integrated with GitHub Actions on this GitHub repository. So when you go to GitHub Actions, and then here, then I additionally created one more GitHub action to demonstrate how this repository can be collaborated with internal inner source infrastructure. But let me now focus on this GitHub Actions. For example, then you can see this tab, and then you can click this, and then you can even see that, then there are build status and then deploy status. Then you might see in details, and then, whether there are errors or not. And some general messages are publicly open, so that open source developers easily figure out, then after their commit has been approved from their pull request, and then they can easily figure out that, that this Azure Web Static web pages are very stable or not. And so that they might need to, they can contribute their the documentation on this community version of open source. Then they can contribute more on documentation, not only for documentation, but also that they can contribute with their actual open source version of this roster API. So then let me see then another GitHub action, roster API test. For this, it is very interesting that I purposely set this path inclusion. as I explained already earlier, then this roster API is for roster API source codes, and the other folders are for Azure Static Web Apps infrastructure for documentation. So then this roster API test only work for this roster API folder, while then some other features on general stuff on Azure Static Web Apps only work on all the paths except roster API folder. So it separates into two types of GitHub actions by specifying some folders or specific files or and so on. And this GitHub action is a little bit special because it actually calls by connecting to existing infrastructure with a secure manner. I already exported my Azure credentials and your SSH username, server host, and private server key. And then, this actually calls the server infrastructure internally used. So then when you would like to only disclose general for GitHub actions for CI/CD general stuff, but however, if you don't want to disclose actual internal infrastructures, and then you can integrate with such SSH manner or any kind of manners. And note that those secrets are stored on this secrets tab on settings tab on this repository. And after storing this tab, then I can see what are the actual values. So then I can only update. So those values are stored with secure manner, and those values are managed by GitHub with very secure manner, which is very cool. So this also demonstrates that how open sources and inner sources can co-work and coexist together. So as I mentioned earlier, the roster API is a private repository for their inner sources, while this repository is for public-facing repositories. So some documentations and also some APIs specification and some other version of open source version of code repositories needs to be opened. And then GitHub Actions actually bridges with two ways. One is how to implement CI/CD structure infrastructure with GitHub Actions, and the second one is how to integrate with existing Azure DevOps infrastructure by connecting with SSH commands and so on. So hope that my demonstration is very helpful for you to better figure out how inner sources and open sources coexist together when the size of business is growing and growing and growing. So then this is end of my demo, and then let me hand over to Anthony to conclude our talks.
Thank you, Ian. So to recap, the way we're building software is changing, and open source plays an ever-increasing role in application development. The combination of both Azure DevOps and GitHub provides a highly productive environment for building all types of modern applications used in enterprises today. There are a number of integrations that make it easy to work with both Azure DevOps and GitHub, but over time, GitHub should be the direction organizations are planning to move. GitHub features such as code spaces provide a quick, convenient way for developers to access the environments they need to build, test, and run modern applications. As cloud-hosted environments, they can be provisioned quickly and support different performance requirements in a cost-effective manner. And in terms of growth, GitHub helps you grow from a strictly inner source model to one where you can safely and selectively move some work into the open source community where it could grow and be nurtured by that community. Before we wrap up our talk, here are some resources we'd like to share where you can learn more about many of the things we've spoken about today. You'll be able to find the links in the shared resources for this talk. Finally, thank you from both Ian and myself for taking the time to watch this presentation, and please feel free to continue asking us questions in the Q&A window now. Thank you.
Hi everyone, I'm Adrian Lee. I'm one of the GitHub solution engineers here, based out in Sydney.
Hi, my name is Victor Viria Ampanan. I'm an Azure engineer at Microsoft. Disruption affects every industry and no company is safe. We have heard about the example of Blockbuster replaced by Netflix, Lyft and Uber disrupting traditional taxi industry, and even Twitter changing how we consume news and media. And in today's competitive market, you need to adapt quickly or get left behind. GitHub is the home for world's code. The platform has over 50 million developers working on over 150 million repositories. This making up to 1 billion contributions yearly. This is why we are one of the largest developer communities on Earth. We work with some of the top open source projects like Kubernetes, Apache, and Docker. Global enterprises such as Disney and Ford has adopted our platform. The innovative company like Netflix and Uber have been using GitHub for some time now. It can also integrate with the popular DevOps ecosystem that you know and familiar with. This put GitHub in a unique position on open source work. And we use this to build products that help developers such as yourself do what you love. Today, we see 3 key challenges that impact company ability to innovate. First, attracting and retaining developers. We know that developers drive innovation. Unfortunately, we just don't have enough of them out there. To hire and retain a skilled developer, you need to create a great working culture and working environment. You need a great platform that they can collaborate and already familiar with. Second, it's around the open source. I'm talking about open source software that lives inside your supply chain of software. According to the Open Source Security Risk Assessment Report, 99% of code include open source components. Any security risk in these components can translate to security risk in your software, and that is a big concern. And lastly, we've seen an increased number of DevOps implementation over the years, especially with cloud adoptions. Most companies are struggling to do this well. Even with successful implementation, most are not optimized. And now, my friend Adrian will show you how GitHub can help. Over to you, Adrian.
Thanks so much, Victor. And GitHub can really be an essential part of your digital transformation. And by leveraging GitHub, you can really collaborate across between different teams by developers sharing lots of different ideas, but also making sure that the code you put on GitHub is secure. And on top of that, by leveraging a lot of the capabilities of GitHub Actions, you're able to automate a lot of the manual workflows that your organization has today. And with a lot of the collaboration capabilities within GitHub, a lot of organizations are working in silos and teams aren't collaborating with each other. Just by simply leveraging GitHub and having a lot of your developers going to a central place to discover lots of code, teams are able to discover other teams and groups' code and start to collaborate on how we can make that code better. If I wanted to discover and build a new ARM template that potentially one of my teams have already built, I can simply go into GitHub and reuse lots of those code internally within my own projects as well. And with that, this also drives lots of developer talent. Developers love to work on problems which haven't been solved. And by simply collaborating across all these different teams, developers are able to reuse some of the existing templates and code that your organization has today and use that to solve even newer problems rather than constantly reinventing the wheel. But we also want to make sure that the code you put on GitHub is secure, and this is where a lot of the security and compliance capabilities of GitHub comes in. With our new GitHub Advanced Security offering, you're really able to secure your source code by leveraging a lot of the code scanning capabilities that are available on GitHub, but also making sure that the dependencies you leverage within your source code are also up to date. And we use this by doing Dependabot and Code Cure capabilities. Dependabot really scans through your source code and automatically creates a pull request, so you know which versions of your dependencies you need updated to, and we combine that with the powers of CodeQL, where it scans your code the minute the developer pushes the code back onto GitHub, and we ensure that the developer is aware of any vulnerabilities the minute they start coding as well. But it's not just about security and collaboration as well. In order to achieve a true DevOps culture, it's also about automating a lot of the boring manual processes that your organization has. And that's where we really come in with GitHub Actions. With our new Code to Cloud DevOps capability, GitHub Actions can really allow you to deploy your code from GitHub onto any cloud platform of your choice or even to any of your on-premise data centers. And it's not just a CI/CD solution, it's also a workflow automation tool that says, hey, I also want to fire off an integration back into Slack or potentially into Teams in order to leverage some of these capabilities. By automating a lot of those manual processes that your organization has today, you're really able to drive out a lot of those inefficiencies and let your developers work on the things that really matter. And that's where the power of both GitHub and Azure can really work together. By leveraging GitHub as your code repository platform and using that to deploy to all of your Azure services, you can really help drive that collaboration between developers by tagging people on GitHub and also making sure that your code is secure on GitHub before even deploying to a lot of those Azure services. And now we'll go into a demo into how Victor demonstrates how you can deploy a lot of your code from GitHub back into Azure.
Okay, so now we're in our demo. So the scenario here, I have an application, front end, AngularJS, that's a single page application that will be hosted on Azure storage account with the static website enable, so turn that on. The backend is the Node.js API that will be hosted under Azure Function. So that's a serverless architecture inside Azure. All right. We have the application here, and this is a resource group that we target. Now, I already had an environment, target environment that is a dev environment, so function, storage account for that. And this is the application. So URL. So it's live one, right? So refresh. So things are working fine, seems to be. Okay. So now, one issue that we are seeing now is that we have an alert that shown that we have a potential security vulnerability in one of our dependency that we use, and obviously I'm using Angular application, and my NPMs, some of the packages is not up to date. So we've seen that there's an alert shown here. Okay, so we're gonna go look and see what's going on. So you can see that under Dependabot alert, Dependabot is an AI inside built in with part of the GitHub, and it's available to everyone. So this continuously scan your application while you, as you're submitting and committing and things like that to your application, then this is what you will see, right? And it will continue to get scanned, and if there's any issue, it will tell you, right? So this is a file that is saying that it's having an issue with, and within here it's saying that the Node.4 version recommend that 10 or later, and so assuming that we are using the older version, all right? So getting back, so if we look into here, now let's search for Node.4 in this page. Node.4. So, there you go. So let's see, as expected, it's running on version 9. So what we need to do is we need to fix it. So we'll come here. Before we go in and fix that, what we need to do is that since we only have a dev environment and I'm attending to pushing this to a production, So what I need to do is that I need to go request my operation team to make a request to my operation team to create a production environment for me, right? That's mean, and the good practice would be separating this resource group to a different environment. So it could be prod and non-prod, but just for the simplicity in this demo, I'm just going to use the same environment, resource group here for the production environment. All right, so how I do that, so I'm going to come in here and then create a pull request. Not pull request, issues, right? Create a new issue. I had a template here called environment request template. So I'm calling it new prod environment for application name. So we'll call it GH to do, right? Application name, GH to do, resource group, GH demo RG, environment name, prod, and justification demo, all right? And in here, we're looking for SPA and API. Now, I'm going to click submit. So this create an issue. Now, I'm going to play a different role now. So this is a developer. Developer submit a request, and operator will monitor this repository, and they will see the request issues being created. So their role come in here is that we have a workflow that detect a label, and the label that say approved. So we're going to assign a label to this issue. Now, as the operator, I'm approved the creation of the environment. Now, when the label approved is being created, it trigger off a production environment build. So this is a workflow that target infrastructure as code, which is ARM template here. Okay, so it's going to go through a process of running it. I'm showing you the workflow files here. So this is type, which is label. Look at a label here. Check out the code. Now we have an action, custom action. This, what it does is it requests, it's an action called request parser. So what this does is that it go into the request that I just created and parse all the necessary information and output it as part of it. So you can see throughout here that I'm using a step that called parser output, and then it will output things like ARM template that we're going to use, the resource group that we're going to use, name of the application, so on and so forth, right? So that's what the parser does. And this is a custom action, and you can create your own action. The way to do it is going here. Within the code, I have a .github folder, and within the .github folder, there's the actions and the name of the action, which is a request parser. So, and this is a YAML that defines what the action does, or what parameter does it takes, and what its output is to. So you look at a YAML file. So this what output does it expecting to get, what is when it run, what is run again. So we run again this request parser.js. So that's a JavaScript file that is going to run and parse throughout the issue that get created. Okay. You can see that it parses through certain things and grab the information that we needed, and the output as part of it are here. Now, for the actions, go back to the action again. It's still running, so we're going to look at a workflow file. Now, so that's a parser. Then we're using ARM template. So these are the ARM template action. So ARM deploy action that will deploy using ARM template and deploy that to target Azure resource group. Now, you need a credential to basically, before you can do anything, you have to log into Azure before you can run these Azure action. Now, the credential is stored as a secret, right? For you that don't know the secret does, before we go into that, I want to show you something that in GitHub Marketplace, there are lots and lots of action, first party and third party, likewise, right? So we do have action that created by Azure. So the Microsoft Azure endorsed this. So we create these actions that would consider like a third party or first party, not third party, first party from Microsoft, right? So this is the action. So the Azure login created by Azure, which is the one here. The ARM template one. So deploy Azure container. So there's a lot of these in here, as you can see. And this is growing in number. So if you look at this few months ago, the list wasn't this long and we're growing in it. Previously, the only way to deploy anything to Azure will be via Azure CLI. This one is the first one that was created, right? Now, and obviously there are other actions that you can use, which I'll show you in other part of this. And again, you can create your own custom action as well. Now, as part of the documentation, if you get lost during creation of the workflow, there's a documentation here, and this kind of easy reference that you can go in and actually looking at it, and like event that can trigger the workflow, how you can manually run the workflow, etc. So these are things that you can using for reference, and also, I mean, there are documentation in the GitHub, and then there are also GitHub Lab that you can use as well for this to learn and practice. Now, I think the action should be ready, so I'm canceling out of this because we're not going to commit anything. Yep, the action is done. So let's come in here and refresh. Now we do have a production. All right, that's good. So now, as part of this, I need to grab some information out here before we can deploy. So get publish profile. So I'm going to download this, open it up, copy information on that, and then I'm going to come in here and settings. Now, I didn't show you secret earlier, and that's what we talked about. So it's a secret. Secret here is sort of like a variable that's being kept and then actually encrypted as part of storing of the of that. So I have one that called Azure Function API Publish Profile Production. So I'm going to update this one with the right publishing profile. Now it's updated. So you can store as many secrets in here. These are encrypted, so when you put it in there, you can't see what it actually looks like. So all you can do is just update it. Okay. Now, as mentioned before, that we have an issue here that we need to get fixed, and what we want to do is we're going to create a branch called Dep for patching. Patch. Okay. Now I'm going to clone that, copy that, and what I'm going to do, let's close this for now. So what I'm going to do is I'm going to get clone that into my my local repo. Okay, so I'm going to do git. So let's go into my right. I'm doing something off the screen right now, so just bear with me. But I'm going to clone it. Okay, let me share this. Not sure you can see, actually it doesn't work, so that's no problem. Let's delete that. Okay, so this is a command line, so I'm going to do is just git clone, okay, from the particular branch. Okay, do the git clone. All right, so now I have a code that is cloned. Let me check a few things here. Okay, so let's see. All right, so let's go into our code now. So I'm gonna all right, code dot. Okay, so I'm open VS Code. Okay, let me making sure that. Okay, we're gonna do another capture of my window that targeting VS Code. So I get clone to it, and now I have in VS Code. So what I need to do is come in here, right, and now I need to update that package. So what we do, so npm install. All right, just double check here. It'll take a few minutes. So let me find the node for that we want to do. So let's do version 9. So just give it a few minutes. While it's doing that. Okay, bear with me, it takes some time. So let's see what we got there. There's one higher severity and a more, so let's do that. Let's get fixed and npm audit fix. I might have to do the npm update one more time to get that thing done, and then we'll be good to go. Okay, let's do, yep, so now it's up to date. So you can see that version 10. So what we're going to do now is do the git commit message patch. Call it security patch. Okay. Oh, what's going on? So let's do it from here. Check security patch. Okay, so now what we want to do is we want to push to a different branch. So let's do push to let's do this git push origin from master to dep patch. I think that would be call it, right? Okay, see if it's going to work. Okay, skin there. All right, sounds good. So let's see where we at. Now, this should trigger off some action when it's done pushing. Okay, still waiting. Let's see where we're at on the Okay, so that looks like it did the trick, so let's go check on it. Now, what's going on? Why there's no pull request though? So we're gonna create one. Let's see, let's look at the branch first, making sure that that looks good. So let's look at the different files. Let's create a new request. Okay. So before that, let's look at the code first. So let's go back to code for a second here. Yeah, so that's right, security patch. So if you look at the here, we look at the things that change, right? For example, it'll be package lock here, and that should be version 10 as we expected. So let's go find that. Yep, version 10. Sweet. Okay, so pull request again. So we just saw that. So we created a pull request from here. All right, one file change. Let's create a security patch. Sounds good. So now, as you see, when I trigger this security request, the pull request, now it's going through action. So now it needs to go compile and build and deploy this to make sure that things are good before we deploy. Okay, so we're looking at action here, and security patch is working. Now it's going to do, so we have two actions in here, Node.js or Cicd, so that deploying Azure function, and that's target the dev environment that's in here. So if I come here and refresh this targeting the dev environment, right? So we got dev and prod. So that pushing code to dev environment in this workflow, so I can show that to you as well. Come here. Now, environment that we target here is the dev one. So the app name, environment name, is in the security, which is dev. That's going to push it. So in here we got check out the code, make sure up all the Node.js necessary. We're using Node.js version 14, Node 14. Run the install, build, test if there's anything, and then publish it to Azure function. All right. Now you can see that pushing it out, it's working. Once that's done, we got another code in the workflow that gonna deploy the Angular version of it. Right, so this deploy Angular, pretty much the same thing. Check out, do some caching of the node, set up Node.js, do some find and replace to making sure that all the things in here, like the API that's referenced to pointing to the right Azure function runtime instance, and then and then go ahead and install the npm run. So that create Angular package files to ready to deploy, so distribution package. And then the last one is we're using Azure CLI to publish that to Azure Store. So you can see that using AZ command there. Okay. Now while this run, say security patch success, so the function got pushed. Now it's pushing the front end. So this is a scenario where we can say, okay, well, this is going to production. Before it's going to production, we want to test and making sure that the dev environment is working correctly. All right. Once it's done, I'm going to test it. So this is a dev, right? And then I'm going to show you that the production is not working currently. So that's the same one. We'll just change from dev to prod. See, it's not working because we haven't deployed anything to it yet, right? This is going to take a little bit of time, but let it do its thing. Now, same goes. So the scenario is, okay, I'm pushing it to the depth now, and then when there's a pull request, now it's pending. So we're looking at it. Okay, so merging is being blocked at the moment, but all the check has passed. Before I do that, we're gonna perform a pull request. So before that, we're gonna do merge pull request. Okay, looks like the pull, the action is done. Yep, all good. All right, I think so. Still publishing, but it looks good to me, and that should work. So what I'm going to do is just going to go ahead and merge this request in. All right, because it's need a reviewer. So I'm just okay. I'm gonna go and merge. I can review it myself because I'm the creator of the request, so that's fine. So what that does, though, if you look at it again, that triggered that action. That now is going to deploy to production. Now, so we went from dev to production, right? Dev's done. That looks good. So you can show. So we're gonna get some oranges, right? We're just gonna get a box of it, and then save. So we're good. So looks like it's look good. We can delete that. We got the slice of bread done. Now come back to the action here. It's working. Now I have two steps here. So release and then API and then release the Spark. So this is running in parallel. So that's a cool thing, right? So if you look at the code itself on the workflow, I can have multiple jobs running, and I even target different runtime. So one is running in the Windows, and another job's running on the where is that? Another job running on Ubuntu. So Windows, Linux running the same time in parallel because I can deploy the code one to different target, which is front end here and back end here, right? So I'm doing it and running in parallel. So this is going to save a little bit of time as well in terms of deploying as opposed to the one in the dev environment where we don't sync that up. So it's just it's a sequential step. So you got to do one and then the other. All right. And so that's cool. Now, while it's done, right? So let me wrap this up. So all in all, so what have we done so far? We got an application that's already in production or in dev stage, but then we realized that there was a security risk or vulnerability occur, which is triggered by the dependent bot in GitHub, and this is available to everyone. So by that, so we want to making sure that it's secure. So as mentioned in the presentation earlier, that dependency security vulnerability that find in your dependency can translate to your security holes in your software. So we want to patch that. So that's what we did. So we patch it, put it through a dev environment, and then making a pull request and merge that into a production, right? And then we're using ARM template on a different repo with the Azure ARM deployment to publish the to publish or provision an environment for production. So this is what we did with the entire demo here, right? So I hope you learned something from this. And so let's go back and look at Azure function that was just finished deploy, I believe. So if you look at the function here, yep, it's all good. Looks like it's there. So now we just wait for the front end to come up. Okay, so it's deploying now, any minute. Okay, it's done. So let's check it out. And there you go. We got the production. So we took it from that code to that, patch it, and all the way to production. Okay. So that concludes our demo. And hope that you enjoy it. Back to Adrian.
Thanks for that demo, Victor. And as a summary, if you want to get started with GitHub and Azure today, you can easily click on one of these links over here. And just remember that GitHub is your central place to go for a lot of your world source code as well. And by leveraging GitHub and deploying into the services into Azure, it can really help your developers make that easy first step right back into Azure by leveraging GitHub Actions.
I'm Steve Fargo from Equinox IT in New Zealand, and today I want to talk to you a little bit about evolving a DevOps security practice. First of all, I'd like to give you a little bit of an introduction to myself. As I said, my name is Steve Fargo. I work for Equinox IT here in New Zealand, and as a senior consultant. I've been working in the IT industry for nearly 35 years now, and I've gone from testing and software development and hardware and voice over IP through to people management. And in the last 4 years working for Equinox IT, I've been developing agile practices, agile software development, and lately helping customers achieve their DevOps journey. So let's get into it. We're in an era of unprecedented economic uncertainty. Many organizations face constrained resources as they navigate the new business challenges. Virtually overnight, companies have seen the need to accelerate their digital transformations. And as security teams are charged with protecting ever-growing digital footprints, they now face added pressure to cut costs. To secure their environments, organizations must develop new digital capabilities and break down data silos. Data and information are the lifeblood of the transformation, but they also increasingly attract cybercriminal activity. Traditional security approaches have failed us, and a hardened perimeter is at best a security blanket, but it won't hold. So I want to talk a little about the impact of a breach. The average time to identify a breach in 2019 was 206 days, and the average time to contain that breach was 73 days. And the global average cost, and we'll talk a little bit later about how that breaks down, was 3.9 million. So how did we do things in the old days? In waterfall times, like testing, security was the very end of the DevOps or the SDLC lifecycle. So effectively, a solution was designed and built, and at the very end we tested it, and that included security assessment. But like testing, we see that the closer to production we find defects and security vulnerabilities, the more expensive they are. And if we look at the diagram, we can see that where we find vulnerabilities in the code, at the time of creating that code, it's 1 times the cost, whereas when we get to release or production, it's 640 times the cost. So the cost is exponential. And as technical debt grows, so does the opportunity for vulnerabilities and security holes to exist in our code. Modern code approaches, open source libraries, and cloud dependency all increase the risk profile. So what must we do? Shift all the things left. As with testing, we need to integrate security into all aspects of our DevOps practice. We shift security left to reduce the cost of those issues uncovered. And security teams must be part of the development team. And when I say development team, I'm talking about an agile development team of cross-functional people. And we automate everything possible, so we reduce the human factor. And the more automation we have, the more portable our code is, and the more modular it is, and the more we can reuse. So when we look at some of the costs of security vulnerabilities, I've detailed 5 of the main ones here that I see. The first off is infrastructure cost. So in here we're talking about server uptime, we're talking about power, we're talking about HVAC and the cost of actually running our servers or our cloud. And that all costs money. When we look at build and deploy time, we're talking about build and deploy minutes, which costs as part of our infrastructure cost, and the team time taken to actually execute those builds and deployments, and the time that we lose not developing features when we're actually fixing and remediating problems. When we talk about developer time, we also talk about the developer time to find a defect, work out how to fix it, implement that fix, deploy it, test it, and get it ready for production. But where the costs really start to accelerate is when we talk about our customer impact. The impacts to our customers using our application and that defect and what it causes and the flow-on effects to their customers. And then we talk about corporate trust. How much trust have we lost by introducing a defect into production for our customers? And that is one of those great intangible measures. GitHub and Azure have all the tools you need to quickly build secure applications. We can perform static and dynamic code analysis to find vulnerabilities in your code. And we use SEML, which GitHub recently acquired. We can examine dependencies of the application and the dependencies of open source on components. And we can check for security risks using features in GitHub like Dependabot. We can ensure secrets are not in our code and are stored securely using the Microsoft CredScan and also as a key vault. So I'd like to talk about why I don't believe in DevSecOps. Like DevTestOps, testing and security should be an intrinsic part of our DevOps lifecycle. Like testing, we have to shift security left. It's a journey, not a destination. We can't just drop security into our pipeline and say the job is done. It must be part of a continuous improvement culture. And culture is really important. And here I say culture is more important than the tooling that we use. Security is everyone's responsibility. It's a cliche, but it's very, very true. People are the most important. And similarly, the people are the weakest link. Developers will find a way to work around some security control that stops them from doing their job. So what do we need to secure? Well, anything exposed to the internet. Our web apps need to be scanned from the outside. We need to see what the customer sees and what those vulnerabilities are. And all of our code and pipelines need to be scanned internally. The external vulnerabilities are really only part of the puzzle. And we need to ensure that our entire pipeline is secure. Things like code quality, so linting, code coverage, all of those static analysis tools. Password and secret storage need to be secure as well, so we use products like Azure Vault for that. Code scanning, using Microsoft Security Code Analysis Toolset, so that covers linting, Microsoft Cred Scan, security risk detection, and static analysis tools as well. With software as a service, we need to make sure that our infrastructure is secure. Software as a service does that for us. So it takes away a lot of the work that we need to do to ensure a secure infrastructure by moving it into the cloud. And containerization is part of that solution as well sometimes. There's no point securing our application if the underlying infrastructure that it sits on is insecure. So our architecture is important as well, ensuring separation of concerns and environmental isolation to make sure that if an environment or a solution or an architecture is compromised, that compromise doesn't extend to other aspects of the solution. And what else? Things like automated test suites to reduce our exposure to vulnerabilities from code change. Every time we introduce new features or change a piece of code, if we're not testing it and it's not automated, there's a chance that someone might miss it. We have dependency scanning and the life cycle of our code dependencies, i.e., again, Dependabot from GitHub. We must use a least privileged model to ensure that our services and our applications run with the least amount of privilege required to do the job. We talk about things like ephemeral environments where we use Azure Resource Manager to spin up an environment, deploy to it, test, tear it back down again. The less time an environment is available, the less time an attacker has to get in there and see where else they can get to and what damage they can do. We need to ensure that we're constantly reducing tech debt. Tech debt, again, as I say, is a place that vulnerabilities and security holes can hide. And we need to ensure a robust logging and monitoring regime. But ultimately, this is a culture shift, where the goal is for every member to be accountable and responsible and work towards ensuring a secure pipeline and secure application delivery. So it's all about that culture and mindset. And building on that people aspect, the culture of your teams is key to embracing and championing security and DevOps. Now what I mean by that is an agile development team is a cross-functional, self-organizing team of people who are responsible for delivery of solution from end to end. So they're there to deliver all aspects of the solution, not just the code. We work with our customers to empower them to bring solo departments into the fold, ensuring that security, testing, and all of the stakeholders are involved in all aspects of the solution delivery. And that is all about messaging and education and talking to people, basically. So while security is that accountability of the security team, it is everybody's responsibility. That cliche is certainly true. And again, we talk about shifting left and automation. So the more we automate, the more modular our code is, the more portable it is, the more reuse we get out of it, the less time we spend rewriting things. And it enables our development team to actually spend time doing higher value tasks rather than doing the mundane tasks. We automate those. So what are the security challenges of DevOps? So reading that bottom piece there, we say the traditional security methods are not flexible enough to adapt to the above changes. And those changes are things like cloud adoption, the fact that we're doing really quick, really rapid and frequent releases into environments. We have more complex development environments, both around the dependencies that we're consuming and other aspects of that. Constantly changing applications in an iterative software development lifecycle, we are possibly pushing out tens of iterations of code in a single day. And the developers are responsible for operational responsibilities now. but also the operational people that are responsible and involved in the development aspects too. And we're going to look at some of these challenges in the coming slides. So our cloud services require a new approach to security. So the shift from on-prem and traditional corporate networking to cloud and distributed computing means that our workforce can be anywhere and they can access our resources from anywhere using any kind of device or a range of different devices. And with a growing digital estate, our customers need the ability to effectively secure that down. And this includes services like software as a service, infrastructure as a service, and platform as a service. So as cloud-based threats and risks continue to evolve, the attackers focus on our growing footprint and vulnerabilities and attack services across the cloud landscape. The average enterprise has over 1,000 cloud services running, and there was a 28% increase in cloud attacks in the past year. So one of the tools we've developed to help with this is the Equinox IT Cloud Foundations Framework. Derived from the Microsoft Cloud Adoption Framework, it's a package of scripts and programs that help ensure secure provisioning, configuration, and administration of Azure subscriptions. When we look at subscription security, we're talking about RBAC components to ensure security is integrated into our day-to-day development process. Things like security verification testing, so built-in security controls for Azure services. A Cicd pipeline quality enforced by policies, like Azure policy. These include quality checks using tools like SonarQube within the pipeline, and we'll look at that a little bit later. Service principal-led provisioning, connecting our Azure subscriptions to Azure DevOps. And continuous assurance with the help of automation runbooks in Azure and Azure Resource Manager. So we're preventing security state drift in the wrong direction, looking to help stay with current security improvements, and encouraging adherence to operational best practices. Azure Monitor and Azure Security Center monitor traffic, look for threats, and fire off alerts. Security telemetry gets routed to Application Insights and is viewed on the Power BI dashboard. The Microsoft ecosystem provides tools necessary to enable CI/CD in a secure sense. And some of these things we'll look at in the following slides. I want to talk about network protection. There's three aspects to it. Network isolation, which we're working on currently with some of our customers. Network isolation prevents unwanted tenant-to-tenant communication, and access controls block unwanted access. Virtual networks allow information flow between discrete subscriptions or workloads within a tenant and allow us to connect them together. And we can secure our communications with the Azure Cloud through tools like ExpressRoute, which is a private fiber link. If that's not appropriate, we can also use site-to-site VPN, depending on the scenario. We look to strengthen our cross-cloud security posture. So Azure Security Center continuously assesses the security state of your cloud resources across virtual machines, networks, apps, data services. It even monitors several workloads running in other clouds and on-premise data. Azure Security Center allows you to set your policies to run on management groups, across subscriptions, and even for an entire tenant. And you can use Security Center to receive recommendations. It can detect and block advanced malware and threats for servers, protect cloud-native services from threats, protect data services against malicious attacks, and we can use advanced analytics to detect threats across IaaS and PaaS services. And one of the important tools in our toolkit is the Web Application Firewall. So this is a firewall that runs on an Azure Application Gateway, and it provides a centralized way of protecting your web applications from common exploits. So one of the keys to this that I really like is that you don't have to modify your backend code for the WAF to work and the WAF to protect your web apps. Now this is the most common solution we use for protecting web apps in Azure. And it protects you from a lot of different vulnerabilities like SQL injection protection, cross-site scripting, protection against things like HTTP request smuggling, misformed packets, protocol violations, crawlers, scanners, all those horrible things. You can monitor attacks as they're happening in real time with the WAF log, and you can create custom rules for one or more web application groups. And we can also geo-filter traffic to stop people from various countries or regions from accessing your data. I want to talk a little bit now about the encryption that's actually built into Azure. So there's three components to that. So there's encryption at rest, which is protecting your disks. So Azure Disk Encryption enables IT administrators to encrypt Windows and Linux ISVM disks. Organizations that fail to protect their data in transit expose themselves to man-in-the-middle attacks and similar things. So we need to encrypt our data on the wire. And data in use. So we look to services like Azure Key Vault to protect our secrets and our keys. And this can be backed by HSM, the hardware security modules as well. And lastly, we need to protect our developer endpoints. So here we're talking about identity using AAD. We're talking about protecting the endpoints themselves, so Microsoft Defender, Advanced Threat Protection. We're protecting our apps using Cloud App Security, and protecting our email and our documents using Office 365 Advanced Threat Protection. So recently, for one of our customers, we built a Windows Virtual Desktop-based developer endpoint solution so that we could actually protect their developer endpoints based on a security approach. And that protects them from external security threats. And it's really all about securing your organization with a zero trust strategy. And it's all about that strategy. So to make implementing this model across your organization achievable at scale, let's look at how some of those pieces work together. So the identity and access management, this enables you to verify users and make informed decisions based on access policies. Information protection and cloud security solutions help enforce decisions and protect resources across your entire environment. And threat protection solutions provide intelligence to further strengthen your security posture. So I want to talk to you now about how we're helping some of our customers. We're working with a significant finance domain customer at the moment, helping them on their DevOps practice. We're doing a lot of re-engineering of their pipelines, moving everything into YAML, using YAML templates, and helping them modularize their pipelines so that they can be reused by other projects and that they are consistent. We've helped them and worked a lot with them on the uptake of Azure Key Vault for storage of their secrets. And a lot of the work, and I'll talk to you about that in the coming slide, around migrating them from TFS into Azure DevOps. We're working with them on configuration as code, and again, YAML pipelines are a large part of that, but as well, environmental stand-up and shutdown of environments, configuration as code. Infrastructure as code is in progress. We're working with them on that, and part of that is going to be containerization as well. We're working largely at the moment on the security of their pipelines and their build and deploy pipelines using a least privilege model. So we're helping them ensure that the build agents and all of the services that run to actually build and deploy their code run in a least privilege model. We're using on-prem deploy and build agents to ensure that the organization has absolute security control over how their code is built and deployed. And part of that is the separation of concerns around separating those environments and the virtual networks that they sit on. And we're implementing code scanning for them as well. The great thing about this is that as their teams evolve, they're evolving in their DevOps maturity, and DevOps maturity is really about ensuring that the code base is in a deployable state. So they're not chasing their tails, fixing problems and keeping things alive. They're actually working on keeping the code ready to deploy, and that shows a very mature DevOps organization. And we're working really hard on bringing their security teams into their development team structure so that security is involved right from the pull request state all the way through to the deployment of the code in production. We've done a lot of work, as I said, with secret storage, so Azure Key Vault, massive uptake of Azure Key Vault in this organization. They have recently migrated from Team Foundation Server, so all their repositories were stored there. We did a big project where we scanned all of those repositories for a whole bunch of stuff. So it's in the list there, but there was passwords, secrets, URLs, high entropy strings, file types, so where they were storing actual keys in their code base. So we've worked hard with them to move all of that out, move everything into Azure Key Vault, so their code bases are now secure. And we've also worked on the architecture of that Azure Key Vault and the design. So we're using Azure Policy for enforcement at source and allowing us to assess compliance as well. The implementation and management groups to support that Azure Policy, and the least privileged approach for user and administrative access. So here we're talking about management plane versus data plane access. So the data plane access, the developers are able to manage and maintain the contents of Azure Key Vault, where at the management plane, the administrators can manage the key vaults but do not have access to the data itself. And that's part of that enablement of the dev teams. Obviously, we've turned on soft delete and purge protection, and we have a robust logging and alerting setup as well. And configuration as code, again, those YAML pipelines are really a big part of that for both build and release. And we're using YAML templates to ensure that features like deploying to an IaaS web app server, for instance, are reusable by any project in the organization. We've written a lot of PowerShell functions that allow custom pipeline actions that aren't currently available, including functions like enforcing the least privilege model, where the service account has to be elevated to perform a privileged action and then de-elevated afterwards. And we're working to reduce that human factor, where automation and scripting helps us take away the human factor that can introduce errors. And now I'd like to just do a quick demonstration of how easy it is to put some simple security measures into your Azure pipeline, your DevOps pipeline, and how we can very quickly remediate the errors that it finds.
So I'd just like to demonstrate really quickly how easily we can install and implement some security scanning in our pipeline. So at the moment I have a project here that's building in an Azure DevOps pipeline. The code repo itself is hosted in GitHub. That's okay. So the job is basically, it's a web app. It builds the project, publishes it, deploys it to our as a web app sitting in our Azure subscription. Let's quickly go and have a look. We can see that there it is, running on the internet. The problem is, we don't know if this web app is secure or what's going on with it. So let's add in some scanning. So here's our YAML pipeline. Fairly simple. Download some dependencies. It runs a build, .NET Core project, and it does a publish and then pushes the zip file up to our web app. So what we're going to do here is, before we publish anything, we're going to insert a product called White Source Bolt. White Source Bolt does a bunch of scanning of our solution for us. 2 lines, that's it. That's all we need. So let's save that. And we'll give it a sensible name. At the moment I'm committing directly to the master branch just because it's easy, rather than running pull requests. So there we go, it's already triggered the pipeline to run. We'll wait for our Microsoft Toasted agent. So it takes a few minutes, but while it's doing that, the repository itself, the project, is easily buildable. It's accessible for anyone from the Microsoft Learning Labs. So you can basically create this project in your own repository, in your own Azure DevOps instance, and you can have a play around with it. And there are a bunch of labs around various different aspects of security. It builds pretty quickly. We can now see that the White Source Bolt task is now part of our pipeline. So what White Source Bolt is a DevOps extension. You can see over here I've installed it, and it is part of our pipeline tab. And what this does is it examines the project, generates a report, and it makes it accessible here. So once this pipeline is finished running, we'll go and have a look at that report. There are a number of other products that you can use for this kind of thing. SonoCube is one of them. I think I may have touched on that in some of the slides. Okay, so that's all done. So now let's go and look at our white source vault report. Oh, that's not great. So we've got some high vulnerability score dependencies in here. We can see this Lodash library is causing us some problems, and it's saying that we need to upgrade to the latest version. Okay, well, let's do that. So if I just quickly make sure I have the latest. Great, cool, we're up to date. So we're just going to use npm to install Lodash at latest version. Okay, and I see at the bottom here it's telling me that there's some low severity vulnerabilities that we can fix really quickly, so let's just do that too. Audit fix. Okay. So four of them couldn't be updated, but that's okay. So let's push this back up. Oops. Okay, so if we now go and look at our pipeline, we'll take a few seconds. Okay, one new run, here it is, there's a commit. So as we can see, it runs pretty quickly, and once again you can get this from the Microsoft Learning Labs and play around with it yourself. You can get a free Visual Studio subscription that will allow you an Azure DevOps instance, and you can also get a license to get some free Azure minutes as well if you want to run a public web app. Okay, and we're done. Let's go look at our new report. See if we fixed anything. Yay! So all the red dependency issues are gone, and we're now just down to our medium severity or medium vulnerability score. So when we look at a white source vault report, so it's telling us all of our dependencies here. It shows us our license risks and compliance, and we can look at some outdated libraries if we want to update all those, and it gives us an inventory as well. And that shows just how easy it is to implement some really quick, really simple security measures into your pipelines.
Well, I hope you found the demo and the talk useful, and continue to keep asking questions in the chat box. And thanks everyone for your time.
Hi, everyone, and welcome to DevOps Virtual Summit. My name is Sudhir, and I work as Azure Dev PMM with Microsoft New Zealand. And I'm very lucky to talk to you about the collaborate and accelerate your projects in DevOps Virtual Summit. And briefly, what I'm going to talk about is I'm going to talk about three different areas in a software development lifecycle, where how you can actually collaborate and how you can manage your projects. And in the situations where developers are working remotely, what are the tools that you can actually leverage to accelerate your development time and your collaboration as well. So with that, let's just go ahead and talk about the three areas that I'm going to talk today. So one of the area that I'm going to focus on the Azure boards and how we can actually manage the work that has been assigned to us as a developer, and how we can actually look into the various sprints that we have planned, how we can look into the backlogs, how as a developer or the project lead, I can look on to the dashboards and the reporting side of it, just to make sure that we are on the track when it's come into the project development and delivering the project, right? And then I'm going to talk about it, a new feature of Visual Studio, which is Live Share. What is Live Share is all about, and what are the scenarios where we can use Live Share. And I'm sure that's going to be very useful for you in this situation where developers are working remotely. And then last but not the least, we're going to talk about code spaces. Now, what code spaces bring us on the table is it basically provides an environment where we can actually code from anywhere, from any devices that we have, right? So what you can do is from anywhere you can actually go ahead and log in, and you can work on the code that you are working on or that you have been assigned to work on, right? So we'll talk about these three features, and with that, let me just go ahead and get started with the topic of the presentation, which is Azure boards, right? Now, why Azure boards, right? I mean, when you look into the software development lifecycle, when you start working on a project, right, as a project lead and as a team members of the software developers, you basically come together and talk about, hey, let's look into what we need to do, right, and divide a different task among ourselves, and then let's go ahead and work on it, right? So you're dividing a task, dividing the work item that needs to be done to complete a particular project, right? But it's not easy if you double click on each of the areas, right? I mean, the number of projects that you are doing in the organization, the number of developers that are involved in building that software, right? As well as how much time that they can spend on a particular on a project. Developers might have some holidays as well, right? So you need to keep track of all these, right? And at the end of the day, you want to actually focus, hey, how can I look into a bigger picture of where we are in terms of, the project delivering, right? So that's where the Azure boards come into the picture. You can track your work with the Kanban boards, backlogs, team dashboard, and not only that, you can actually do the custom reporting. So any point of time, if you feel that any of the reporting that you're looking forward is not there in the Azure boards, then what you can do is you can write your own queries, and we're going to look into that as well, right? Now, the whole idea, as I mentioned, is track the work that has been doing by the developers on that particular project, right? What stage they are in, how many team members are aligned, how many tasks are there, how many is in progress, how many has been completed, or maybe, you have a different milestones, maybe, how many have been approved, how many have been checked in, things like that, right? In Azure boards, we have built-in Scrum boards and as well as the Agile boards and various planning tool, which you can see on the right-hand side, which can help you to run the sprints. Maybe you want to run weekly or bi-weekly sprints. You can actually not only configure that, but you can actually monitor and take an action on that as well, right? Now, as I mentioned, it probably provides you more insights. That's also there. You can look into the health and the status of your projects with various analytics tools and the dashboards, which is available out of the box, right? In the Azure boards, another feature that we have, the Work Items Hub, right? Now, this is the area where you can actually create a new work items. You're going to create a new user stories. You're going to create maybe work items, epics, or maybe a bugs, right? And not only you can define what needs to be done, you can also define who's going to participate or maybe who's going to take that particular task to complete it, right? Now, if you're working in a big team, you might have 10 developers or 15 developers. So as an individual developer, what I want to do is I want to actually look into what all tasks that has been assigned to me, right? So that's where the filtering comes into the picture, right? So I can actually go ahead and do the filtering and figure it out how many tasks that has been assigned to me, or maybe I can see how many which are not completed, and so on and so forth, right? I can also go ahead and query the work items within the projects or across the project. So in an organization, maybe there are multiple projects and I'm participating on the multiple projects. Any point of time, if I want to look into in a particular projects, I want to see the detailed information about a task, I can actually go ahead and query that as well. Now, once the work item has been assigned to me, what I'm going to do is I'm actually going to start working on it, right? And at some stage of point, depending on the milestones that we have defined in our team, I'm going to actually keep moving those tasks, right? So, for example, maybe we said, okay, we're going to do from doing and done. I'm just saying these three pillars. So what I can do is once I pick up a task, I'll move the task into the doing milestone so that I can see what all tasks that I'm working on this particular time. And then once I'm done with that, I can actually go ahead and move that into the done stage, right? So once I'm done with that, I can actually go ahead and look into how many items that has been done, how much time that I've spent, and as well as if I want to look for any information which is not available out of the box, that's where the extension comes into the picture. I can install the extension if I have the permissions to install, and then I can actually go ahead and look into the various aspects of my contributing onto that project, right? And live updates. So as soon as you do any changes onto your task, it automatically gets updated live onto your board. So you don't have to refresh, you don't have to wait for the latency. It happens automatically, right? Not only that, if I want to do, let's say I have completed a particular task. Now I have checked in some code. Now what I want to do is I want to associate the check-in ID with my task. I can actually go ahead and do that as well, right? Now what that helps me is it basically helps me to figure it out. Hey, if somebody completed this task, what code has been checked in against it, right? So if that ID is associated with my task, I can actually easily go and look into that into my repo, right? So that's also I can look into and I can associate as well. Now, you also have something called Backlogs Hub. So what we can do is we can actually go ahead and look into the backlogs that has been assigned. So it might so happen that all the tasks that has been given, I'm not able to complete in that particular sprint. Maybe when I go into the next sprint, I'll have some backlogs with me, right? So what I can do is I can actually look into those backlogs. I can actually go ahead and set the priorities for the backlogs so that I can be more focused on the sprint that I'm currently in, right? Then we have a sprints hub. So generally what happens is, maybe during the daily meetings or maybe weekly huddle or weekly meeting that we have at the end of the sprint, we need to look into where we are as an individual or maybe as in a team, how many tasks has been completed, what is the capacity planning, what is the burn down chart, which basically helps us to determine if the team was on track or completing the sprint plan or not, right? Or maybe there are some, let's say some task which has going to take longer time and which is going to be a high alert for the team to look into, right? So all these information will easily available in this Sprints Hub. I can actually look into my dashboards, I can look into the backlogs, I can look into and plan the capacity as well. Now, as I mentioned earlier, right, I mean, there are a lot of information which is available, but at the end of the day, we want to do, find out some information which is probably relevant to my work, right? So what I can do is I can actually leverage the query hub. I can go over there. I can actually go ahead and create the queries which I'm interested in to look into. I can save those queries so that later part of time, if I'm going to come back, I can run the query again rather than creating a new query. I can pin these queries to the dashboard for quickly doing the monitoring and looking into the status. And if I want to do the bulk modifying the work items, I can actually go ahead and look into that as well. And then we have the dashboards, which provide the real-time information. So the dashboards, you can add various widgets, which you can see on the right-hand side, the widgets that I'm interested in. And what I can do is, at the one glance, when I log into my DevOps boards, I can actually look into how we, maybe as an individual or as in a team, we are doing, right? How many tasks that are active, how many bugs that have been resolved, how many user stories are open, and so on and so forth, right? With that, let me just switch over to my browser, and let's go ahead and look into the demo of Azure boards. So this is my browser. I log into my dev.azure.com. If you're new to the Azure DevOps environment, when you go to the dev.azure.com, it probably give you options to create a free tier, which can actually help you to look into, what are the features and capabilities that DevOps provides, and you can get started from there as well. But if you already have the DevOps environment, you might be seeing this once you log in. You can actually, if I go to the main page, it's basically going to show me all the organization that I'm part of, right? And if I want, I can create a new organization, considering you have a permission to it, and then you can create the projects as well, right? Now, I've already have a create a project, Smart Hotel 360. I'll just go ahead and click on that. And if I go into the overview, so this is kind of on a wiki page where I can actually define what is this project is all about. And if I go to the dashboards, now you can see here I can actually add all the widgets where I can see how as a team we are doing, right? So you can see these are the work items that has been assigned to me. There are 2 epics and 1 task that has been assigned to me. Some are new, some are on the to-do state, right? And all items assigned to the team members, and you can see the breakup of it over here. How many items are in progress, how many work item has been assigned, how many unfinished work. And then I can look into the burn down chart as well over here. How many 25% you can see completed, what is the average burn down. And then if I look into a little down, I can actually look into how many bugs without the repo steps by assign. And then I can look into the backlog item as well. Right? Now, any point of time, if I want to change this look and I want to add a widget that I'm interested in, I can, let's say, click on the edit. And let's say I don't need this markdown widget over here. I'll delete that. And now what I can say is I can actually go ahead and search from the widget which is available out of the box. So I can say, let's say I'm going to add the team members, right? Or maybe I can click on the sprint overview as well. And then I can actually go ahead and look into the sprint capacity. And I can say done editing. And if I look into the full screen, this is how it's going to look like. So now you can see on the left-hand side how many days of work that has been remaining, how many items that has not been started yet, right? And I can actually go ahead and look into the backlog information over here in the dashboard itself, right? Now, once I have the view of the projects, now what I can do is I can actually go ahead and go into the boards, right? So when I click on the boards, you can see we have the various options over here, right? I can start looking into the work items, boards, backlogs, sprints, and so on and so forth. But more importantly, if I go into the project setting over here before I get into the boards, I can go into the project configuration. When I created the project, I can actually go and define which either we're going to use the Scrum methodologies or Agile. I can go ahead and choose that. And as you can see, I have the various iteration for this particular project, right? And if I go into the areas, so there are 2 areas, mobile and web. So we have the mobile application and the web application on which the team is working on. And then I have the teams defined over here, right? If I click on any of these teams, I can further drill down onto that as well. Now, if I go into the teams configuration, I can actually go ahead and define the backlogs. I can define the working days for the team, right? And I can also define how we're going to working with the bugs as well, right? Now, if I go to the areas, probably going to show me the areas. It's coming up. Here's code. So these are the iteration. And if I go to the areas, so now you can see these are the areas, and the default area is the my mobile area, right? But if I want to change, I can actually go ahead and make web as a default area for the team, right? Now, if I want to add more areas, you can actually go ahead and add. If you want to add a new child, you can go ahead and do that. Or if you want to remove, you can remove that as well, right? So all these configuration, you can do it from here with respect to the projects. And let me just go back into my project, go into the boards. And now I'm going to go on to my boards over here. And let me just go started with the work items, right? So once I click on the work item, what I can do is we can actually go ahead and create a bug, epic, feature, impediment, product backlog, task, or test case, right? And we can provide the various information. For example, I'm going to add a new epic or maybe a product backlog item. So let's say epic. And then I can actually go ahead and define the title. If I want to assign to someone, I can go ahead and do that. And maybe then I can actually go ahead and define area and the iteration, right? So in the iteration, you can do, we have the multiple sprints. So currently the sprint 2 is going on. So if this particular epic is, I'm going to look into the sprint 3rd or 4th, I can actually go ahead and define that as well. And I can define the area as well, right? Whether this particular epic or a feature, if I'm going to create, is a part of the mobile solution or the web solution, I can actually go ahead and define that as well, right? I can add the description over here. And I can actually go ahead and add a comment as well. And I can add people, I can add emojis as well. On the status side, I can actually define the start date and the target date as well when I'm going to look into the complete. And I can set the priorities. What is the priority for this particular epic? How much effort is required? What is the business value for it? And the time criticality as well, right? Now, let me go to the sprints over here, and I can say, okay, let's discard the changes. So this is, as you can see, if I go onto the entire team, I can look into the entire team sprint, or if I want to look for the mobile or the smart or the web team sprint, I can actually go ahead and do that as well, right? If I go to the mobile, I should be able to see all the tasks. But for now, I'll just go on to the entire Smart 360 hotel team, and I can actually go ahead and look into the task board, right? Now, as you can see over here, I have 44 hours of tasks which I need to do, and there are 72 hours of work in progress, and this is the task that has been done. I can actually go ahead and change the sprint as well. So if I want to see all the tasks for a particular sprint, let's say sprint 1, I can actually go ahead and look into that as well, right? Let's say I'll go into the current sprint, which is sprint 2, and I can say all that has been assigned to me. I can actually go ahead and look into that as well, right? Then I can to the change on the view option. For example, if you want to look into the planning or the work details as well, you can click on that and it will show the work detail as well. So I'll just click on off. Now, once I'm doing the task over here, right, and let's say the code has been checked in for review, right, and I can say remaining work is 0 at this point of time because the code has been checked in, and I can just go ahead and save and close. And once it's saved and closed, I can actually go ahead and move this from to do maybe in progress because it's in review. So once it's reviewed, then probably if there is no comment from the reviewer, what I can do is then I can move it on to the done, right? I can also look into the backlog, and I can actually go ahead and, if I want to create a new item as a product backlog, I can actually go ahead and do that and add it over here, right? Now, if I want to prioritize my backlogs, I can actually go ahead and do that and say, I'm going to move this particular backlog onto the sprint 3, 4, 5, depends on, which one I want to move on which sprint, right? The other thing is I can actually go ahead and set a capacity, which basically defines how many hours that I'm going to work per day, right? So my capacity is 8 hours, or maybe 7 hours or 9 hours, depending on the organization. And then I can actually go ahead and define the days off as well. So if I have any planned leave, I can actually go ahead and define that as well, that I'm not going to work on that particular day, right? So I can define all this, and this is going to be my capacity. And now what's going to happen is if I go to the backlog, probably the task board, and what I'm going to do is, let's say I'm going to assign this particular task to myself, and if I go into the capacity, let me change this one. So I can see there's a 12 hours of work that needs to be done over here, right? So if I open this particular task, and this is 12 hours, let me just change it to the, let's say 15 hours, and I'll save it and close. And if I look into the capacity over here, you can see I have 15 hours of task that's been assigned to me, right? Now, if I go ahead and change, and I'm going to say, just for the sake of test purpose, I'm going to say this is going to take more than 150 hours. And if I go to the capacity, I can see that it basically giving me a full red line over here. That means I'm over of my capacity, right? So as you can see, 150 hours of task that has been assigned, but eventually I have 64 hours of work to be done, right? So I can actually look into my working capacity and the work that has been assigned, and then I can work with my teams and make adjustment and maybe reassign the task to someone who has a better bandwidth rather than me. So let's go ahead and make it to the 15 and save it. Okay. The other thing is, if I go back onto the boards, now over here you can see these are the new tasks. These have been approved. These are the tasks that are there in the build and test. And then once it's done, once it's deployed, I can actually move the task into the deployment stage, right? But there's two things that you notice, right? I mean, this particular organization for this particular project have these stages, right? But in your environment, you might have different stages, right? And then each of these stages, you can see there's some limitation that has been defined. So number 5, here also number 5. So if I go over there, it basically tells me that 4 items out of work in progress, limit of 5 items, right? So I can actually define the limits as well over here. Now, how I can change these stages and how I can make these limits, that can be done over the configuring the team setting. If you click on this icon over here, and if you go to the columns, now you can see I have new, approve, build and test and deploy. So in the new, if you want to add a new column, you can go ahead and do that. Or maybe if you want to create a different one, instead of new, approve, build and test and deploy, you can go ahead and do that as well, right? And if I go to the approved, as you can see over here, this is the work in progress limit that has been defined, 5, right? If you want to change to 10 or 15, you can actually go and do that. But I'll leave it as it is, but if you want to change, you can go and do that. And then you can actually go and split your column into doing and done, right? So remember, let's see if I can move this a little down. So under the build and test, we have the column has been break down into doing and done. So I can actually go and do that as well by just checking this option over here. And then I can define the swim lane as well. You can define the backlogs if you want. You can click on the new items and you can create it as well. So I'm going to say this is going to be test demo epic. Just go ahead and add it. And if I just double click on it, I can again go ahead and define how many effort is required, start date and target, which you talk about it. And I can define it's going to move the mobile area path and iteration. Maybe we're going to look into the iteration 3. Just go ahead and save and close. Right. And if I come back onto this sprints and come back to the analytics, that's where you can actually look into the burn down trend, right? You can define the start date and the end date, and then you can actually define what you want to look into, task backlog, or you want to look for the backlog items, or maybe you want to look onto the bugs, right? And then you can burn down on remaining, maybe some of remaining hours, or maybe some of efforts, or maybe you want to look into the sum of the business values, or maybe you want to show the non-working days as well. All this you can do it over here, right? Now, any point of time, if you feel that you need some extra information, you can go into the query tab, and then you can say new query. And here you can actually go and define all your filters, right? So I can say what is the work item. So the work item type could be, let's say it's going to be feature, and the state is going to be any or accepted, right? And I can add a new clause as well. So you can say where work item is feature, state is accepted, and let's say accepted date is less than, you can say start of the day, or maybe start day minus 7 days or 30 days, something like that. And then you can actually go and run the query. Now there's no results, so I'll just run with this. Okay, and maybe I'll say change the filter again and run the queries. So now you can see I get all these results, and then you can actually go ahead and if you want to create a chart, you can create it, but you have to make sure that you save your query. So if I go back over here, I can save my query, and I can say this is going to be my demo query, and I can save it. And then if I want to create any charts, I can create a new chart onto that query, and I can say work item type, and let's click on OK, and I can get that as well, right? Okay. Now, what happens, if you need more information, or maybe, you require some, for example, you want to write a SQL queries to, get the data out of it. One of the extensions that you can add is like WIQL Playground, which allows you to query your data in a SQL language, as you can see. But we have a lot of extension available in the Visual Studio Marketplace. So some of them are free, some of them are on trial. That means you have to pay. But what you can do is you can actually look onto those extensions, and you can actually go ahead and add those extensions onto your Azure DevOps boards, right? And like this one, WIQL Playground that I've added over here, I can write a SQLite queries, and I can run it over here, and I can get my results right then and there itself, right? Now, if I'm more comfortable writing SQL queries, so I can add more filters over here. I can define the custom columns that I want to retrieve, and I'll be good, right? Now, apart from that, as I mentioned, you have the more extensions as well available. Now, this is great, but what about if you want to see this report and show it to the user in the organization. Maybe my CEO wants to look into this report, and maybe he doesn't want to come onto the DevOps environment. Maybe he's more interested to see that information in Power BI because the CEO level, the business stakeholders look into the reports in the Power BI and day out, right? So how about creating a report in Power BI, which gets the data from the DevOps and showed over there, right? So that's where Power BI has a connector to connect to the Azure DevOps. So once you connect to that connector, it's basically going to ask you your organization and the projects that you want to connect to authenticate it. This is how it's going to look like. So as you can see, it basically gives me all the information of the data sets in my project. And then I can actually go ahead and look into, let's say, work items, all history by month, for example. And I can actually go ahead and load that information. And once it gets loaded, as you can see, now I need to just go ahead and drag and drop the data that I want to look into. So for example, I want to look on to this state, the iteration path. Let me just change the control to table, right? And then it assigned to whom. I can look into that. And then I can also go ahead and add a filter. So for example, where is my filter? There you go. So I'll just click on that and I'm going to say add assign to. As soon as I click on the assign to, it basically shows me the information of all the items that has been assigned to me, right? So this kind of a report I can actually go ahead and create in Power BI, and then I can deploy it into our organization workspace so that the people can actually go ahead and look into what's happening in the Azure DevOps in terms of the project's different development stages, right? Now, this is great. Let's move on to the next section of the presentation. Now, let's think about it, right? I mean, so far we have all the project tasks distributed across the developers, right? Now, what happens is, when developers are working, they want to do the collaboration, right? Now, generally, they do either by screen sharing, which is not good, but this is that's one of the options that is available to them. Considering in a situation we are living now where we are working remotely, what you need to do is either you do the Teams meeting, or maybe you use some third-party tool, or maybe you want to call your colleague and discuss the project and then come back and make the changes in your code, right? Now that's where the Visual Studio Live Share come into the picture. And let me just move on to the next step. So the Live Share is basically an extension of the Visual Studio and the Visual Studio Code. What it provides, it basically provides a real-time collaboration between the developers so that they can work on the piece of the code. They can edit, they can debug it, or maybe they make the comments and so on and so forth, right? Developers can work on their own IDs. That means I don't need to move out from my own ID. I can still work on that. It doesn't require me to do an extra setup for the collaboration. And I'm going to show you, whenever I want to do the collaboration, I can do it from the Visual Studio Code itself. So I don't need to set up some third-party application, for the collaboration. No need to share your entire screen. Maybe you have your emails open on your desktop, or maybe, some other documents, which is very important that you don't want to, by any chance, want to share, right? No need for sharing the code snippet or the call stack. That's another way generally we used to do, right? I mean, if the collaboration is not happening perfectly on the screen sharing mode, then probably I'll just go ahead and share the entire call stack to my colleague and, let them review and then come back to me, right? So all this is not required. No need to clone your report, set up the environment. That means you don't need to check in your code somewhere and then, ask somebody to do the changes over there so that you can pull it again back, right? It works on Windows, Mac, and Linux as well. That's the feature of the live share, as Naim mentioned, right? Now, where actually and what are the features that it offers? You can actually go ahead and debug. You can share the terminals. You can share servers. You can do the audio calls as well, and you can do the live editing. What are the use cases? It is very helpful if you want to do the pair programming. If you want to, teach or maybe do a walkthrough of your code to your mentors in your team or maybe the junior developers in your team, right? It can be useful if you want to do a quick assistance, you want to do code reviews, or maybe you want to do the interviews and, for example, if you want to ask someone, hey, this is the environment that we have shared, just go to your browser and just, try to, can you just write a 4 line of code to do this? You can actually go ahead and use for it as well. All right, so now I'm going to show you a demo on live share. So as you can see, I've opened my Visual Studio Code environment and I can go into the live share extension. If you don't see this extension on your code framework, then you can install from the marketplace. And once you install this extension, you can click on that. And then you can say, I want to share a read and write collaboration session. And it's going to generate a session. I'll just go ahead and copy the link. And then I can send it to my colleague. And what they can do is they can actually go ahead and type in the browser. And let's go ahead and initiate that collaboration session in browser. So it's going to initiate a session. And once it does it, it basically probably going to ask me for the permission. So I'm going to say, just go ahead and sign in as a guest user. And as soon as it's done that, on the left-hand side, I'll probably going to get a request. So whether I want to approve or reject. And once I'm going to approve that, then probably we can able to see the same, and I can, actually look into the comments, which is posted by the guest user. So as you can see, it's still trying to, waiting for the host approval. I should have it over here. So I'll say accept, read, and write. And let's move it over here. And you can say, it says I have joined. So here, as a guest user, I can provide some comment, and I'm going to say, please add comments. All right. And as you can see on the left-hand side, I can see all the changes which is coming over here. And the other thing that I can do is I can actually go ahead and initiate an audio call, or I can initiate the chat as well. So I'll just click on the chat, and I'm going to say, okay, I agree. And I will add comments later. And once I'm done with that, I'll just go ahead and, as you can see over here on the right-hand side, I got the comment. So as a guest user, I can say, sounds good. And I'll get right. So as you can see, the experience is pretty seamless. I don't have to install anything, and we can actually do the live share and, take an advantages of not installing anything, not spending too much of time on installing any software. We can just working from the Visual Studio Code by using the live share extension. With that, let me just go back to my PowerPoint presentation. Now, the another thing is that we have is the code space, which basically allows developers to have the dev environment anytime, anywhere. So what that means is they can actually code, build, test, debug, deploy with the complete development environment from the browser itself. So even if you're a remote location within a different laptops, you can still go ahead and do the code with that, right? So if you have new machines in a remote location, you don't have to install a lot of tools and libraries into that. What you can do is you can actually leverage the code spaces in such scenarios, and with the Visual Studio Code extensions as well, right? So Visual Studio Code is going to be your edit tool, which is going to be the same across different devices that you're using for the development, right? And how you're going to do is, earlier the code space was available with Visual Studio Code and the Visual Studio 2019 and with the GitHub as well. But in the recent announcement, the Visual Studio Code Space is now moving into the GitHub Code Spaces as well. And that's the example or the sample that I'm going to show you in today's summit. All right. So for the code space demo, as you can see, I'm on my browser. I connected to my GitHub account, and I'll go into the code spaces. And what I can do is I can create a new code space. And what's going to happen is behind the scenes is basically going to create a compute environment for me, which is probably going to be Linux at this point of time. And then I can actually go ahead and execute my program. Now, the libraries that we need to run our program, what we can do is we can actually either use the predefined containers, or maybe we can, create a definitions of what all require into my container, right? Or maybe in my code space environment. So for that particular case, you can see I've already have a code space created. And this particular code space that I have created is based on the container. So what you need to do is you need to have create a .dev container. And under that, you're probably going to need a dev container.json file, which contains the information about your containers, what libraries that you need to install on that container, right? Either you can use predefined. Visual Studio team already had predefined dev containers that you can use it. But if you want to create your own, you can go ahead and do that. But just make sure it follow the naming convention so that whenever the visuals, the GitHub code spaces going to create the compute environment, it basically going to look for this folder and the file. And whatever libraries that are defined underneath, it's basically going to apply that onto the compute environment. Now, once it's created, once the Visual Studio Code is up and running, as you can see, it's connected to my GitHub repository, and I have my file over here. Now, what I can do is I can actually go ahead and run my command. I'll just go ahead and close this off, and I'm going to create a new file, text1.png, and this is going to be GitHub code space demo 1. And I'll just go ahead and run this. Okay. Now, I don't have this library, so what I'm going to do is I'm going to install this over here and say matplotlib. So it's going to connect the binary and going to install on my environment. And once it's done, I can actually go ahead and run the file. Okay. And once it's done, on the left-hand side, you can see the text1.png file is created. And once I click, I can actually go ahead and look onto the outcome, right? Now, I can go ahead and commit these changes onto my repository. So I'll just go ahead and say adding code during demo. All right, that's fine. It's okay to commit. And then I'm going to push all these changes. Okay. And now, if you want, you can, once your work is done, probably if you want to stop your code space, you can go ahead and do that because all the information is residing out of your container, right? Your code, your libraries or the binaries which is required, it's already there outside of the compute environment. So you can actually go ahead and delete it, and then later point of time, whenever you need to spin up your code space environment, you can go ahead and do that, and you will get all your files and everything back, right? So that's an example of code space in very short details. All right, so that's all I have for today's presentation. I hope you learned something. And again, if you have any questions, feel free to type in your question and answer. And if you want to connect, I've already shared my social pointers with you. I'll be more than happy to answer you or help you any question that you have. And enjoy your learnings. Thank you so much.